Hey guys, good evening, and welcome back again to your Unacademy NEET English channel. I hope all of you are doing great, having a good time. So people, let me know in the chats if all of you can hear me, if I'm perfectly audible, visible to everyone. Good evening people, good evening. Good evening and welcome back. So let me know quickly in the chats with our trademark emoji fire. Yeah? If all of you can hear me, if I'm perfectly audible, visible to every one of you. Perfect. I believe I am perfectly audible, visible, yeah? All right, wonderful. So my dear students, as you all must be knowing, for the upcoming 3 days, we are going to have the problem practice sessions. As I told you in the yesterday session, we shall be solving almost like 1500 questions in just 3 sessions, right? And the first session is going to be today, okay? And today we are going to do all the types of the questions from the chapter Solution, Kinetics, and Electrochemistry. Yeah? First of all, let me know in the chats if all of you have revised these 3 chapters or not. Say yes or no in the chats. Say yes or no in the chats. I just want to know. I just want to know whether you have revised these 3 chapters or not. Quickly, everybody. Perfect, guys. Perfect. Amazing. So let me tell you, whatever types of the questions can be framed from your class 12 physical chemistry, all the types of the questions I'll be showing you in the today's session. Okay? So, as I told you in the yesterday's session, in total we shall be solving almost like 1500 questions. Whatever questions can be framed, can be made from these chapters which I'll be doing today, right? I'll come up with all those types of the questions. You need not to worry about any single thing. Okay? It is just, I would want you guys to be ready with your pen and paper. Are you guys ready with your pen and paper? Are you guys ready with your pen and paper? Let me know quickly in the chats. Because we are going to mutually solve the questions. Okay, some of the questions you will solve, some of the questions I will solve, right? Let the session be very interactive. Someone is asking about the session duration. I have no idea about the session duration. Let's see exactly what happens. Yeah, let's see exactly what happens. Well, I know my voice is coming out to be differently today because I have got cold, cough, etc. So I might sound different today, but I think that's okay. Yeah, I think that's okay. Perfect. Chalo, let me have some water and we'll start. Okay, by the way, can you write down your states? Where are you guys from exactly? From which state you guys are watching me right now? See, I'm live from Kashmir right now. I'm live from Srinagar. From which part of the country you guys are from? From which part of the country you guys are watching this session from? I just want to know in the chats. I just want to know in the chats. Oh my God. Oh my God. All right. I can see majority of the students are from South. Yeah? Tamil Nadu, Karnataka, Andhra. Okay, Srinagar, Kerala, Rajasthan, Telangana, Manipur. Okay. Kashmir. Amazing, guys. Amazing. Amazing. West Bengal. Wow. Meghalaya also. Yeah, Kashmir to Kanyakumari, yeah? Live from Kashmir. Okay. That's great, guys. That's great. That's great. That's great. That's great. That's great. All right, then. Should we start? Should we start then? So I think we should start with the chapter. Which chapter do you want to start with? I think let's start with the chapter Kinetics. Okay. Let's start with the chapter Chemical Kinetics. Let's start with the chapter Chemical Kinetics. I hope all of you are ready with your pen and paper. Yeah? All right, guys. So directly, let's move on to the first question from the chapter Chemical Kinetics. Look at the question carefully. Look at the question carefully. The frequently asked question from the chapter Chemical Kinetics. My dear students, we are given with a reaction. The rate of appearance of bromine is related to the rate of disappearance of bromide as following. What do you think is going to be the correct answer of this particular question? Think over it. This is the frequently asked question, guys, from the chapter Kinetics. And I want you to flood the chats with the right answer. My dear students, if you look at this particular reaction, let me write the reaction again, which we are given with. We are given with the reaction BrO3 negative plus 5 times Br negative plus 6 times H positive. It gives us what? It gives us 3 times Br2 plus 3 times H2O. This is the reaction. This is our reaction. My dear students, the rate of appearance of bromine, Br2, is related to the disappearance of Br negative. So we have to relate Br2 with what? With Br negative. Okay, we have to relate these two. Now, my dear students, if I ask you, what would be the rate of the reaction with respect to Br negative? Since Br negative is the reactant, so I'll be starting with minus sign. 1 divided by stoichiometric coefficient 5. Okay. Change in the concentration of Br negative divided by time interval, that's dt. Okay. Similarly, if I ask you what would be the rate of reaction with respect to Br2, since Br2 is the product, so I'll be starting with the plus sign. 1 divided by stoichiometric coefficient 3. Change in the concentration of Br2 divided by time interval, that is dt. Okay. Now you can find your options because you're done. You can find your options here. This is going to be the final answer of the question. Yeah. So what is the final answer of the question? Quickly. Dear students, you can just do one more thing. You can take this 3 over here, right? It's going to be minus 3 by 5. It is going to be minus 3 by 5 d of Br negative divided by dt is equal to dBr2 divided by dt. So which one is going to be the correct answer of this question? It's absolutely going to be option D. I believe majority of the students have given the correct answer. Yeah? Amazing, guys. Amazing. Let's move on to the second question. The question was asked in your NEET 2019 based on the similar pattern. See, it's a complete basic question, I must say. It's a complete basic question, I must say. Check it out, guys. Check it out quickly. Check it out quickly. We are given with a reaction. We have to find the correct option. Okay? We have to find the correct option. The reaction that's given to me, that is N2 plus 3 times H2 gives what? Gives 2 times NH3. This is a balanced chemical equation that's given to me, number one. Now, my dear students, if I would want to write the differential form of rate, let me write the rate of reaction with respect to N2 first of all. N2 is the reactant, so starting with minus sign. 1 divided by stoichiometric coefficient is 1. Change in the concentration of N2 divided by time interval dt, which is also equal to With respect to H2, it's going to be minus 1 by 3, change in the concentration of H2 divided by time interval dt. With respect to NH3, since NH3 is the product, so I'll be starting with the plus sign, 1 by stoichiometric coefficient 2, change in the concentration of NH3 divided by dt. Now you can find your options. You can find your options, people. Which one is the correct one? Quickly in the chats. Majority is coming up with option C. Let me check it out. Minus dN2 by dt minus dN2 by dt is equal to 1 by 2 d of NH3 divided by dt. Absolutely, you all are perfectly right. It's option C, which is the correct answer of this question. Yeah. Moving on to the next question. Look at this particular question, guys. Look at this particular question. Think over it. I want the chats to run continuously. Do not stop. Okay, be very, very, very active in the chats. The decomposition of NH3 on platinum is a zero order reaction. Decomposition of NH3 on platinum. So if I write the reaction, we are decomposing NH3 over platinum. It gives us what? It gives us N2 plus 3 times H2. This is the reaction. This is first of all the reaction. As per the question, the reaction follows the zero order kinetics, right? Order of the reaction is equal to 0. Perfect. Order of the reaction is equal to 0. My dear students, if order of the reaction is 0, can I write rate law? Rate law says R is equal to rate constant concentration of NH3 raised power 0. Anything raised power 0 is 1. So let me just erase this part. So I'll say R is nothing but R is equal to K. Point number 1. R is equal to K because the reaction follows the zero order kinetics. Now, my dear students, one more thing. Try to write the rate of reaction with respect to NH3. With respect to NH3, it's going to be minus 1 by 2, change in the concentration of NH3 divided by dt. With respect to N2, it's going to be plus 1 by 1, change in the concentration of N2 divided by dt. With respect to H2, it's going to be plus 1 divided by 3, change in the concentration of H2 divided by dt. Okay. This particular term is giving you the rate of reaction. Even this particular term is giving you the rate of reaction. And I believe this particular term also is giving you the rate of reaction. And I've already got to know one thing. R is nothing but R is equal to K. R is nothing but K. And the value of rate constant is given to us in the question. 2.5 into 10 raised power minus 4. So let me equate it to 2.5 into 10 raised power minus 4. Now what do we have to calculate? The rate of production of N2. The rate of production of N2, the rate of formation of N2. My dear students, rate of formation of N2, as you can see over here, this particular term denotes your rate of formation of N2. It's coming out to be exactly 2.5 into 10 raised power minus 4. So 2.5 into 10 raised power minus 4, right? Number 1. Number 2, the rate of formation of H2. Rate of formation of H2 would be written like this. See, plus 1 by 3 d of H2 divided by dt. This term gives you the rate of reaction. And we got to know it is nothing but 2.5 into 10 raised power minus 4, right? If I multiply throughout by 3, it becomes d of H2 divided by dt is equal 3, 5, 15, 3 to 6, 7. So 7.5 into 10 raised power minus 4 moles per liter per second is going to be the rate of formation of H2 as well, right? So it has to be option 2. That has to be the correct answer of this question. Yeah? Perfect, people? I can see majority of the students have already given the answer. That's amazing. That's great. Moving on to the next question. Look at the next question, guys. Carefully look at the next question. In the reaction A plus B gives products. We have got the reaction A plus B. It gives product. All right. Rate is doubled when the concentration of B is doubled. Rate increases by the factor of 8 when the concentration of both A and B are doubled. Rate law for the reaction can be written as. First thing, my dear students, if I write the rate law, how exactly am I going to write this rate law? I'll say rate of reaction is equal to rate constant, concentration of A raised power x, concentration of B raised power y. This x is order of the reaction with respect to A, and this y over here is order of the reaction with respect to B. Okay, now try to understand. Let me call this as equation number 1. Now, as per the first statement, rate is doubled. Rate is doubled when the concentration of B is doubled. So rate is doubled. Earlier it was R. Now it is doubled. It is 2R. When it is 2R, when the concentration of B is doubled. When the concentration of B is doubled. So we are doing nothing with the concentration of A. but we are doubling the concentration of B. Now it's 2 times B raised power Y. This is your second equation. Okay. Now, rate increases by the factor of 8. Rate increased by the factor of 8 when the concentration of both A and B are doubled. So rate from R becomes 8R when the concentration of A as well as B both are doubled. So it becomes 2 times A raised power X, and this becomes 2 times B raised power Y. So this is your equation number 3. Now these 3 equations you guys are supposed to solve, and you'll be getting the value of X and Y. That's all. Now how exactly you guys are going to solve these equations? Let's get to know that as well. My dear students, if I divide equation 2 with equation 1, what do I get? 2 divided by 1. RR gets cancelled. On left side, I'll be getting 2. This A raised power X cancel, K cancel, B raised power Y, B raised power cancel. So from this side, I got 2 raised power Y. So from this particular equation, I can directly say the value of Y is nothing but 1. Okay? The value of Y is nothing but 1. Correct? Now, if I divide equation 3 with equation 2, what do I get? If I divide 3 with 2, R cancel, 8 divided by 2 is 4, is equal to this 2b entirely cancelled, A raised power X entirely cancelled. So this becomes 2 raised power X, right? So 2 raised power X is equal to 4. When is that possible? That is possible only when X value is equal to 2. So you got the value of X and Y. So X value here is 1 and Y value here is, X value here is 2, X value here is 2, and this Y value here is 1. So find your rate law. R is equal to K, concentration of A raised power 2, concentration of B raised power 1. Concentration of A raised power 2, concentration of B raised power 1. So this is option D, which has to be the correct answer of this particular question. Right? Perfectly done? Amazing, guys. Moving on to the next question. Look at this question. Kill it, guys. Easy. For the reaction between A and B, the order with respect to A is 2 and the order with respect to B is 3. So you have got a reaction, for example, like this. A plus B, it gives products. Okay. If I write its rate law, it is supposed to be R is equal to K, concentration of A raised power X, concentration of B raised power Y. This is its rate law, number 1. Number 2, as per the question, order with respect to A is 2. Order with respect to A means X, so X value is equal to 2. And order with respect to B, that means Y. Y value is equal to 3. So now, how exactly you can write the rate law? It's going to be R is equal to K, concentration of A raised power X, concentration of A raised power 2, and its concentration of B raised power 3. This is your rate law, first of all. Since you got to know about your rate law, now the question says, the concentration of both A and B are doubled. The concentration of both A and B are doubled. The rate will increase by the factor of what? If we double the concentration of A, that means this becomes 2A. This becomes 2A. 2 ka square comes out to be 4. So 4 comes out. If I double the concentration of B, so this becomes 2B. 2 raised power 3 is 8. That 8 comes out. And 8 fourth comes out to be 32. So I would say rate is increasing by the factor of what? Rate is increasing by the factor of 32. Clear, guys? Perfectly done? Yeah? Great. Moving on to one more question. These are very simple, basic questions. First of all, which I'm solving so that you will build up your confidence, and slowly we'll jumping on to difficult questions as well. Okay. Have a look on this particular question. For the reaction, we are given with the reaction. The reaction is given in this format. 2 times N2O5. It gives 4 times NO2 plus O2. This is my balanced chemical equation. Rate and rate constant. Rate and rate constant. So rate, first of all, R is equal to 1.02 into 10 raised power minus 4 moles, liter inverse, second inverse. As per the question, rate constant K is nothing but 3.4 into 10 raised power minus 5 second inverse. Okay. The concentration of N2O5. I'm supposed to calculate the concentration of N2O5. This is the question. Okay. Now, first of all, people, if you look carefully, what is the unit of the rate constant here? It is second inverse. If the unit of the rate constant is second inverse, I would say this reaction follows what? It follows the first order kinetics. It is the first order reaction. If it is the first order reaction, I can write its rate law. R is equal to K, concentration of N2O5 raised power 1. That's how I'm going to write the rate law. Now, my dear students, what am I supposed to calculate? I'm supposed to calculate the concentration of N2O5. So I would say concentration of N2O5 is nothing but it is equal to R divided by K. Perfect. The value of R I know, the value of K I know. Just divide the two, you'll be getting the concentration of N2O5. That's it. So what is the answer coming out to be? Quickly. The value of R we know, the value of K we know. Both the values we have, we just have to divide them and we'll be getting the answer exactly as 3 molar. Yeah? Clear, guys? Clear, 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 quick, 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 quick. Perfectly done. All right. This is the question which you should kill, guys. Tell me the answer of this question, everybody. When the initial concentration of reactant is doubled, the half-life of a zero-order reaction, what happens to that? When it comes to your zero-order reaction, you know, T half is nothing but it's equal to A naught divided by 2K, where A naught is the initial concentration of reactant. And my dear students, if you double the initial concentration, of the reactant, half-life automatically doubles, right? Perfect. Half-life automatically doubles because they are directly proportional. If you double this doubles automatically. Simple. From the expression only you got to know about this particular question. Someone is saying remains unchanged. That's for first order reaction. For first order, T half is equal to 0.693 by K, right? So there it remains unchanged. But this is a zero order reaction. I believe it's clear. All right, look at this particular question quickly. Quickly, guys. I want you guys to be very, very, very active in the chats. Quickly, people. Everyone. Done? All right, let's have a look on what the question says. The rate constant of the reaction A gives B is this. If the concentration of A is 5 molar, the concentration of B after 20 minutes is. All right. So first of all, as per the question, the reaction is A gives B. Rate constant of the reaction K is given to me as 0.6 into 10 raised power minus 3 moles liter inverse second inverse. This is the rate constant. If you look at the units of rate constant, the units of rate constant are telling me that the reaction follows zero order kinetics. It follows the zero order kinetics. From just the units of rate constant, I got to know reaction follows zero order kinetics. Now, my dear students, if you look carefully, initially at time t is equal to 0, the concentration of reactant I'll be denoting with A naught. Okay, this is going to be 0, right? Now, when the reaction starts, concentration of reactant will keep on decreasing, right? Concentration of reactant will keep on decreasing and concentration of product will keep on increasing, right? Let's say at some time t, concentration of reactant left is 80. Let's say at some time t, concentration of reactant left is how much? That is 80. Earlier it was A naught. Now at time t, the concentration of reactant left is 80. Let the concentration of product formed at this time is BT. Okay. Now, my dear students, as per the question, we have to calculate this BT value. We have to check at t is equal to 20 minutes. After 20 minutes, what is the concentration of product formed? This is something which I'm supposed to calculate. Guys, it's pretty much simple. Earlier, the concentration of reactant was A naught. Now, after 20 minutes, the concentration of reactant left is 80. Earlier, it was A naught. Now, it is 80. Earlier, it was A naught. Now, the concentration of reactant left is 80. So, how much concentration of reactant has got converted into product? Earlier, it was A naught. Now, the concentration of reactant left is 80. So, A naught minus 80. So, I would say this is going to give me that concentration of reactant which has got converted into the product. Okay. So, we just have to get the value of this A naught minus 80. Now, my dear students, if I ask you one thing, do you remember the integrated rate equation for the zero order kinetics? I believe you do. As per the zero order kinetics, AT is equal to A naught minus KT. AT is equal to A naught minus KT. So, if I take this AT on this side, so I'll be writing A naught minus AT is equal to what? Is equal to KT. And this A naught minus AT is what? It is basically the concentration of B at time t, which is 20 minutes. So concentration of B after 20 minutes would be equal to what? K times T. What is the value of K? K is 0.6 into 10 raised power minus 3. And time is 20 minutes. So I'm converting this in seconds, right? So this is going to be the concentration of your product B after 20 minutes. I believe this particular question is clear. And after solving, I believe you'll be getting the answer as 0.72 molar. Everybody done? Everybody done with this question? Yeah? A very simple and basic question this is. A bit conceptual this was. I'm moving on to one more. The question was asked in your NEET 2020. Look at this question. The half-life of the zero-order reaction having 0.02 molar initial concentration of reactant is 100 seconds. Rate constant for the reaction is. As per the question is concerned, we have got a zero-order reaction. When you talk about the zero-order reaction, its half-life is nothing but A0 divided by 2K. A0 divided by 2K, number one. My dear students, as per the question, initial concentration of reactant, which I'm denoting with A0. Initial concentration of reactant is given to me as 0.02 molar, right? What do we have to calculate? We have to calculate the rate constant of the reaction. We have to get the value of K. So can I say, okay, one more thing. Half-life of the reaction is also given to me. How much? Half-life of the reaction is given to me as 100 seconds. Every single thing is given. Put all the values in this expression. So I would say K is nothing but A0 divided by 2 times the T half. What is A0 here? A0 here is 0.02. So this is 2 times the T half. T half is nothing but 100 seconds. So when you solve this, you'll be getting the value of rate constant K. And since it's a zero order reaction, so it's going to be moles, liter inverse, second inverse. Am I clear with this? I believe this is going to be the answer of the question. Option D. Simple. I can say a lot of students have already come up with option D. Amazing, guys. Good job done. Moving on to one more. All right. Something is missing here. I think the graph is missing here. The graph was given here. Let me just presume what the question should have been. What the graph should have been in the question. The graph should have been, the given graph is the representation of kinetics of the reaction, the y and x axis, or the zero and the first order reactions are respectively. Concentration versus time. This is first order. Time versus concentration. Concentration versus time. Rate constant versus concentration. Okay. So rate versus concentration. We have, okay, the graph should have been like this. In the question, the graph should have been like this. Well, it's missing here, right? So this is your y-axis first of all. This is your x-axis, right? And the graph should have been like this. Now tell me the answer of this question. Now it's a question for you. Quick. Now it's a question for you. Look at it properly. Guys. This is the question. If you look at it properly, my dear students, if I directly look at option number C, which I've already marked correct, rate versus concentration for a zero order reaction. Rate is independent of concentration of reactant for a zero order. So it's going to be a straight line, right? It's going to be a straight line. So this part is correct. Second part, in case of first order, T half and concentration. You know, in case of first order, T half is nothing but that is 0.693 divided by K. So T half is again independent of the concentration of reactant. So again a straight line, right? So directly your question is done and dusted. It's option C, which is going to be the correct one. I believe you got to know how do we solve these sort of questions. Yeah? I believe it's clear to everyone. Okay. Now, my dear students, moving on to one more. Look at this particular question. The question has been asked in NEET 2022. Look at the question carefully and try to solve this. For the first order reaction, A gives something. Initial concentration of A is given, which becomes 0.001 molar after 5 minutes. Rate constant of the reaction in minute inverse will be. See, A simple basic question. Again, this is, I must say. First of all, you have got the reaction A gives B. This is your reaction. My dear students, at time t is equal to 0, the initial concentration of reactant, that's given to me as 0.1 molar. Perfect. Which becomes 0.001 molar after 5 minutes. So at t is equal to 5 minutes, the concentration of reactant left, which I'm denoting with AT, that's nothing but 0.001 molar. Correct? What do I need to calculate? I need to calculate the rate constant of the reaction. As per the question, the reaction follows the first order kinetics. The reaction follows the first order kinetics. If the reaction is following the first order kinetics, I'll be using the integrate rate equation for the first order kinetics, right? What that integrate rate equation is, you know, K is nothing but 2.303 divided by T. It is log of A naught divided by AT. Perfect. So I can say K is equal to 2.303 divided by T. Time is 5 minutes. Okay. Log of, what is A naught? A naught is 10 raised power minus 1. What is AT? AT is 10 raised power minus 3. 10 raised power minus 3 comes up. So overall, it becomes 10 raised power 2. So it is 2.303 divided by 5 log of 10 raised power 2. Log of m raised power n log m. So it is nothing but, it is 2. So this is 2 here. It is just a matter of calculation now and you are done. What is the answer of the question now? What is the answer of the question now? What is the answer of the question now, quickly? And guys, one more thing. I'll be sharing the PDF of this particular session in my Telegram channel, Wassim Bhat Chemistry Official. What do you think? Absolutely, it's going to be your option B. That's going to be the correct answer of this particular question. Just a matter of calculation, nothing else. Amazing. Look at one more question. Look at one more question, guys. Look at one more question, quickly. An organic compound undergoes a first order decomposition. All right. Time taken for its decomposition to 1/8 and 1/10 of its initial concentrations are T1/8 and T1/10 respectively. Calculate T1/8 divided by T1/10 multiplied by 10. It's again a simple question only, but a bit conceptual. Let's have a look on how do we approach to this sort of a question. See guys. Let's say the reaction is something like this. A gives B. For example, this is my reaction. A gives B. Okay. My dear students, for example, at time t is equal to 0, let the initial concentration of reactant is A naught. This is 0. Okay. Now, it's mentioned in the question that at time t is equal to T1/8. How much reactant is left? 1/8 of initial. So, this is the concentration of reactant left at t is equal to T1/8. Now, similarly, as per the question, at t is equal to T1/10, how much concentration of reactant is left? 1/10 of initial. So, it is A naught divided by 10 molar. Right? So, I got two things here. If you look carefully, I got two things. What are those two things? Have a look properly. What are these two things? The first thing is, at time t is equal to T1/8, the concentration of reactant left is A naught divided by 8. And the concentration of reactant left is represented by 80. Similarly, at time t is equal to T1/10, how much concentration of reactants left? A naught by 10. And the concentration of reactant left is represented by 80. Okay, now we are almost done. Since you know your integrate rate equation, K is equal, or I'll write T is equal to 2.303 divided by K, it's going to be log of A naught divided by 80. This is my integrate rate equation for the first order kinetics. Now, my dear students, if I use this condition here, what do I get? Instead of T, I'll be writing T1/8 is equal to 2.303 divided by K log of A naught divided by, what is 80? 80 here is A naught divided by 8. A naught did not cancel. 8 comes up. 8 comes up. 8 means 2 raised power 3. Log of 2 raised power 3 is nothing but 3 log 2. It is 3 log 2. So it is 3 and log 2 is how much? 0.3. So this is what I got. Let me call this as equation number 1. Now, if I put second condition in this particular equation, what do I get? Instead of T, I'll be writing T1/10 is equal to 2.303 divided by K log of A naught divided by, what is the value of 80 here? 80 is A naught divided by 10. A naught did not cancel. 10 comes up. Log 10 is 1. So this entire term is gone. So let me call this as equation number 2. Now, my dear students, as per the question, I have to get the value of this particular term, right? So let me just do one thing. I have to get the value of T1/8 divided by T1/10 multiplied by 10 is equal to T1/8, this is the value. T1/10, this is the value. So divide the two. This term cancels out. So this becomes 0.9, and 0.9 multiplied by 10, the overall value at the end comes out to be 9. So 9 is going to be the final answer of the question. Right? All clear? All clear? I believe all the things are getting slowly clear to you. Yeah? All right, moving on. Look at this question, guys. We are given the graph between log of AT versus T. The reaction follows the first order kinetics. Choose the correct value of half-life. In case of first order reactions, T half is nothing but 0.693 divided by K. This is the expression for half-life. Okay. So I would say in order to calculate the half-life, what do I need? I need the rate constant. Now the point is, how do I calculate the rate constant? My dear students, if you look at this graph is between log AT versus T. And in case of first order reactions, I'm pretty much sure you would have studied this equation. Log AT is equal to log of A naught minus K divided by 2.303 multiplied by T. This is one of the equations which you would have studied in the first order kinetics. Okay. Now, if you look carefully, you have plotted a graph. The graph is between log AT versus what? Log AT versus T. You have plotted the graph between log AT versus T. If this is Y, for example, this is X. So this entire term becomes M. Sign here is minus, and this term is C. Y is equal to minus mx plus C. Y is equal to minus mx plus C means straight line with a negative slope. And slope here is nothing but slope is equal to minus K divided by 2.303. And as per the question is concerned, what about the slope of this line? It is tan of theta. Theta here is 135. It is tan of 135. Tan of 135 is minus 1. So K value I got to know as 2.303. What are going to be its units? Time is given in minutes. So I'm assuming K, its units are minute inverse. So I got the value of K. And if you got the value of K, put the value of K here, you'll be getting the half-life of the reaction. We are done with this, right? Perfect. Perfect, guys. Am I clear with this? Yes or no quickly? Yes or no quickly? So it's going to be 0.693 divided by 2.3. The value is going to be 0.3. Yeah? Perfect. Moving on to one more question. Look at this particular question, guys. Look at this particular question. In what time will the molar ratio of ethylene to cyclobutane becomes 1? Okay. See, guys, what this question is all about. I'm given the reaction. You have got C4H8, which is your cyclobutane. It gives what? It gives ethylene 2 times C2H4. Rate constant is given. Its units are second inverse. That means the reaction follows the first order kinetics. Point number 1. Reaction follows the first order kinetics. My dear students, try to understand one thing. We have to check at what time will the molar ratio of ethylene to cyclobutane becomes 1. What does that mean? Try to understand. Let's say at time t is equal to 0, the moles of cyclobutane we have equal to A. This A represents the initial moles of cyclobutane, right? So this is going to be 0 in the beginning. Now with time, when the reaction starts, can I say the moles of reactant are going to decrease with time? And the moles of product are going to be increasing with time? With time, moles of reactant will be decreasing. Moles of product will be increasing. Can I say there will be a time when the moles of reactants and products will become equal? And when the moles of reactants and products becomes equal, at that time I can say the ratio of the moles of reactants products is becoming 1. Do you understand? I can clearly say one thing. When moles of reactants and product becomes equal at that time, number of moles of product divided by number of moles of reactant. This becomes equal to 1, right? Simple and basic thing. Now, my dear students, try to understand. We have to check at what time the moles of ethylene to cyclobutane becomes 1. So basically, we have to check at what time will their moles be equal. At what time will their moles be equal? Now see, let's say at time t, let's say this is the time at which the moles of reactants products are becoming equal. Let's say at time t, out of A moles of reactant, X moles have got converted into product. So can I say I'll be left with A minus X moles? These are the moles of reactant left at time t. Now, 1 mole of reactant gives 2 moles of product. So X moles of reactant are going to give me 2X moles of product. I'm assuming this is the time at which these two terms are equal. I'm believing this is the time at which the moles of reactants products are equal. And when the moles of reactants products are equal, their molar ratio will be equal to 1. So I'd say this is the time when 2x divided by A minus X value would be 1 at this particular time. So from here, I can say 2x is equal to A minus X, or I can say X is equal to A divided by 3. I got the value of X. Now, since I got the value of X, now clearly what do I need to do? I need to use the integrated equation. I can say T is equal to 2.303 divided by K. It is the log of A naught divided by 80. Correct? So T we have to calculate 2.303. K value is given in the question. How much? K value is 2.3 into 10 raised power minus 4 log of A naught. I'm writing as such, initial concentration, or you can say initial moles, which is A, divided by moles of reactant left at time t. Moles of reactant left at time t is A minus X, right? So this is A minus X is what? A by 3. X is what? A by 3. So this becomes 3A minus A, 2A by 3. A gets cancelled. So it is a log of 3 by 2. Log of 3 by 2 means it is a log of 3 minus log of 2. It is a log of 3 minus log of 2. I believe this calculation part is clear till here. So this term gets cancelled out. Log 3 is how much? 0.47. Log 2 is how much? 0.3. So 0.47 minus 0.3. It becomes 0.17. 0.17 into 10 raised power 4 would be equal to 1700 seconds. Right? Right, people? So I must say, after 1700 seconds, the moles of reactants products would be equal. Or I can say after 1700 seconds, the molar ratio of reactants and products would be equal to what? Would be equal to 1. I believe this particular question is also clear to you. And you will be able to solve this sort of equation from now onwards. Right? Frequently asked question. This is your FAQ. Frequently asked question. The rate constant for the first order reaction is this. The time required to reduce 2 grams of the reactant to 0.2 grams. So basically, imagine that the reaction is something like this. A gives B. It is following the first order kinetics. Initially at time t is equal to 0. The initial amount of reactant was 2 grams. We have to check after what time the amount of reactant left is how much? Is 0.2 grams. We have to check after what time the amount of reactant left would be 0.2 grams. What else is given? Rate constant of the reaction is given as 4.6 into 10 raised power minus 3 second inverse. So it's a direct question. Just use the integrated equation. I can say your T is equal to 2.303 divided by K. This is the log of A naught divided by 80. So I can say T is equal to 2.303 divided by K is 4.6 into 10 raised power minus 3 log of A naught is 2, AT is 0.2, right? So this becomes 10, log of 10 is 1, log of 10 is 1. So this term reduces to 1, this entire term. So this is, for example, 1, this is 2. So it goes like this. 10 raised power 3 comes up. So 10 raised power 3 is 1000, 1000 divided by 2 is 500. Almost the answer is going to be 500 seconds. The answer is going to be 500 seconds, right? So in 500 seconds, the amount of reactant will reduce from 2 grams to 0.2 grams. Clear, people? Simple basic question, right? Just a bit of calculation is involved and you're done. You're sorted. Moving on to one more. This is something which you should be in a position to solve like in 30 seconds also. See guys, one equation I believe you would have studied in first order kinetics. Time taken to complete X% of the reaction is equal to 2.303 divided by K log of 100 divided by 100 minus X. Have you studied this equation? If you have watched my Game of NEET 2.0, I have given all the details about this, right? Yes, Vishnu, you can consult this lecture. See guys, time taken to complete X% of the reaction. Time taken to complete X% of the reaction. And they are talking about 99% completion. So put the value of X directly as 99% here. So I would say time taken to complete 99% of the reaction is equal to 2.303 divided by K. And this is going to be log of 100 divided by 100 minus 99 is 1. 100 is 10 ka square. Log of 10 ka square is what? Log of 10 raised power 2 is 2 log 10. So this entirely reduces to 2. So this is 4.606 divided by K. Is there any option like this? 4.606 divided by K. This is the correct answer. Perfect. I can see majority of the students have already come up with the answer. That's amazing. That's great. Moving on to one more. Well, I'm not solving this question because it's a similar type of question which I showed you a few minutes back. That how much time would be, in what time the amount of reactant will go from 2 grams to 0.2 grams. That was the question. This is the similar type of question. So you can consider this as the homework question, right? You should be in a position to solve this on your own. It is the similar pattern question. Not solving this one here. Okay, look at this one. Look at this particular question. Find out the time required for 2/3 completion of a first order reaction if the value of rate constant is this. Again, a basic question this is. Again, this is a basic question. So let's exactly see what do we do in this particular question. My dear students, first of all, assuming that the reaction is A gives B. This is my reaction. The reaction is following the first order kinetics. Let's say at time t is equal to 0, the amount of reactant is A0. This is 0. Okay. Find out the time required for 2/3 completion. Time required for 2/3 completion. Time taken to complete 2/3 of the reaction. What is meant by completion of 2/3 of the reaction? That means 2/3 amount of reactant would have got converted into the products. People, if 2/3 amount of reactant is getting converted into product, how much reactant would be left? I took A0. 2/3 of A0 is getting converted. 2/3 of A0 is getting converted. So how much would be left? A0 minus 2/3 of A0. This is the amount of reactant left after 2/3 completion. So this comes out to be equal to A0 divided by 3. So this is the amount of reactant left, and amount of reactant left is represented by AT. Okay? Perfect. Now we are done. Use the integrated equation for the first order kinetics. We know T is equal to 2.303 divided by K. This is your log of A0 divided by AT. So put this condition here. When you put this condition here, instead of T, I'll be writing T 2/3 is equal to 2.303. What is the value of K? The value of K as per the question is 4.3 into 10 raised power minus 4. This is the log of A0 divided by AT. What is the value of AT? AT is nothing, that is A0 by 3. So A0 cancel. 3 comes up. Log 3 is 0.47. Log 3 is 0.47. Now again a matter of calculation and you are sorted. You are done. Yeah? Am I clear with this? I can see majority of the students are coming out with option D. Absolutely, you all are right. It's option D which is coming out after solving the question, after solving the calculation. Am I clear with this? Am I clear, people? Quickly in the chats. Quickly in the chats. Quickly in the chats. One basic question just to boost up your confidence. Tell me. Tell me, guys. What do you think about this one? Quick. Everybody, quick. You should be in a position to solve this easily. Tell me the answer of this question, guys. Quick, quick, quick. I'm not waiting for a lot of time here. Tell me the answer of this question quickly. Everybody. The rate of the certain reaction increases by 2.3 times when the temperature is raised from 300 Kelvin to 310 Kelvin. So basically, when temperature is increased by 10 units, when temperature is increased by 10 Kelvin, okay, rate increases by the factor of how much? 2.3. Rate increase by the factor of 2.3. Okay. Now, if K is the rate constant at 300, then the rate constant at 310 Kelvin would be. My dear students, I believe you would have studied this equation, temperature coefficient. Temperature coefficient is nothing but that is rate constant of the reaction at temperature T plus 10 divided by the rate constant at temperature T, right? What is the value of temperature coefficient? It is 2.3 is equal to rate constant at temperature T plus 10. That means rate constant at temperature 310 Kelvin. Let that be K dash divided by rate constant at temperature T. Let that be K. So K dash is nothing but that is 2.3 times K. K dash is nothing but 2.3 times K. A simple basic equation this is. Okay? You're not supposed to think a lot in this question. It's a basic one. It's a basic one, guys. Right? Look at this one. Look at this question. We are given with a reaction. P naught be the initial pressure of A, Pt be the total pressure at time T. Integrated rate equation is. All right. These sort of questions also I have shown you in detail in the live sessions, I believe. Yeah. Let's exactly see how this sort of equation is to be solved. My dear students, the reaction that's given to me is like this. A gas, it gives 2 times B gas plus C gas. This is my reaction. Okay. This is my reaction. At time T is equal to 0, at time, first of all, this reaction would be taking place in some container. Of course, this reaction would be taking place in some container. At time T is equal to 0, there will be only reactant present in the container. At time T is equal to 0, there will be only reactant present. There will be only A present in the container. Okay. So if I ask you how many gases are there in the container at time T is equal to 0, if I ask you how many gases are there in the container at time T is equal to 0, you will say there is only one gas present. That is gas A. So whatever is the pressure initially at time T is equal to 0, that's entirely due to A, and let that pressure be P naught. Pressure due to B, pressure due to C right now would be 0 because they have not got formed yet. They have not got formed yet, right? Now, my dear students, just try to understand one thing. With the time when the reaction starts, when A starts getting converted into B and C, pressure due to B will be decreasing. Pressure due to A will be decreasing. Pressure due to B will be increasing. Pressure due to C will be also increasing, right? So let's say at time T, pressure due to A is equal to P naught minus X. So pressure due to B would be equal to, this would be 2x because the stoichiometry here is 2. This would be x because the stoichiometry here is 1. So I must say at time T, there are 3 gases present in the container. At time T, there are 3 gases present in the container, right? If there are 3 gases present in the container at time T, I would say pressure due to A at time T is P naught minus X. Pressure due to B at time T is 2x. Pressure due to C at time T is x. Okay. Let the total pressure at time T be PT. Total pressure of the mixture at time T. Since at time T we have got 3 gases in the container. So I must say we have got a gaseous mixture present in the container at time T. So total pressure of that gaseous mixture at time T would be equal to this plus this plus this, right? So it becomes nothing but it is going to be P naught minus X plus 2x plus X. So X got cancelled out. So I would say PT is nothing but P naught plus 2x, or I can say X is equal to 1 by 2 PT minus P naught. I got the value of X. And since I got the value of X, now I can clearly use the integrate rate equation. What is the integrate rate equation here? I would say K is equal to 2.303 divided by T log of. It used to be A naught, initial concentration. It used to be A naught by AT, initial concentration of reactant. divided by concentration of reactant left. Here it will be initial pressure of reactant divided by pressure of reactant left at time t, which is P naught minus X, right? So instead of this X here, I can write 1 by 2 Pt minus P naught. So I think the equation is done and dusted. 2.303 divided by T log of, this is P naught divided by, So if you directly cross multiple, this is 2 times P naught minus Pt plus P naught, and this is 2 times P naught. So 2 times P naught plus P naught makes it 3 times P naught. It makes it 3 times P naught. So this is 3 times P naught minus Pt. Is any option similar to this? 2.303 divided by T log of 2 P naught divided by 3 P naught minus Pt. Yes, option B. So option B is supposed to be the correct answer of this question. Yeah? Clear? These sort of questions can also be asked. This is from the topic kinetics of a gaseous phase first order reaction. Right? Taught you in detail in the marathons. Moving on. Frequently asked question, particularly in your JEE mains. In JEE mains, they are asking these sort of questions frequently. What do you think about this one? My dear students, if you look carefully, I believe you would have studied this particular equation. T half-life of the reaction is directly proportional to initial concentration of reactant raised power 1 minus n, where n represents the order of reaction. This is something I believe you would have studied somewhere. I have taught you in the live marathons. Half-life of the reaction is directly proportional to initial concentration of reactant, or you can say initial pressure of reactant, or you can say initial moles of reactant raised power what? Raised power 1 minus n. So from this particular thing, I can say T half of 1 divided by T half of 2 is nothing but, this is A naught of 1 whole raised power 1 minus n. This is A naught 2 whole raised power 1 minus n. Right? Or 1 minus n I can take common. I can finally write it like this. A naught 1 divided by A naught 2 whole raised power 1 minus n. Right? Now, if you look carefully, guys, this is the half-life of the reaction when the initial concentration of the reactant was this much. This is the half-life of the reaction when the initial concentration of reactant was this much. Right? All the data is in front of you. Okay? So, if I use this equation over here, look at this table. Let this be your T half 1. Let this be your T half 2. Let this be your A naught 1. Let this be your A naught 2. And you are done. T half of 1 is 4. T half of 2 is 2 is equal to A naught 1 is 50. A naught 2 is 100. Whole raised power what? 1 minus n. So this is 2 is equal to 1 by 2 raised power 1 minus n. Right? I can say 2 is equal, this becomes 2 raised power n minus 1. So 2 raised power 1 is equal to 2 raised power n minus 1. I can say n minus 1 is equal to 1. So n value here comes out to be 2. So I would say the reaction follows the second order kinetics. Right? Remember this equation? It is frequently touched nowadays. Okay? I believe I'm clear. What about this particular one? This is again a frequently asked question, a simple basic one as far as your NEET standard is concerned. If the rate of the chemical reaction doubles for every 10 degree rise in temperature, if the temperature is from 50 degree, if the temperature is raised by 50 degree, all right, the rate of the reaction becomes. My dear students, one equation I believe you all would have studied. If the reaction is A gives B, for example, at temperature T1, let the rate of the reaction be R1. At temperature T2, let the rate of the reaction be R2. Is there any equation that relates these four terms? Yes. R2 divided by R1 is equal to 2 raised power change in temperature divided by 10. This is something I believe you would have studied. Now, my dear students, I can say R2 divided by R1 is equal to 2 raised power. We are increasing the temperature by 50 degrees. So 50 divided by 10 is 5. So I would say R2 is equal to 2 raised power 5 times R1. Right? So after increasing the temperature by 50 units, I must say rate has increased by 32 times. Right? Rate has increased 32 times. Perfectly done. Now, if you solve that question, this question I'm expecting that you will solve on your own. Quickly, tell me the answer. I'm waiting. I'm waiting till you solve this. I'm waiting till you solve this. I'm waiting till you solve this. Quick. Everybody. Everybody. Quickly, guys. Quick, quick, quick. Don't take a lot of time. Quick. We are increasing the temperature from 10 degree to 100 degree. So delta T is how much? 90. 90 by 10 is how much? 9. So 2 raised per 9 times. 2 raised per 9 times means 256 times. 2 raised per 9 is 256 or 512? How much is that? 2 raised per 9 is 256 or 512? 512 times. Perfect. So now I'm pretty much sure these sort of questions can be also solved. A simple basic question, people. What do you think about this one? Quick. For the reaction A gives B, enthalpy of the reaction is minus something. Enthalpy of reaction is minus. So delta H is negative. Delta H is negative means the reaction is exothermic. And in case of exothermic reactions, energy of products is less than that of energy of reactants. Energy of products is less than that of energy of reactants. Here you can see energy of product is more than that of potential energy of reactant. Here you can say potential energy of product is less than that of potential energy of reactant. So it has to be this one, right? Clear? A simple basic question again this was. All right. The reaction X gives Y is an exothermic reaction. All right, we have got the reaction X gives Y. It's an exothermic reaction. Activation energy for the conversion of X into Y. For the conversion of X into Y. That means he's talking about the activation energy of forward reaction. That's equal to how much? 150 kilojoules per mole. Enthalpy is 135. Delta H is 135. Delta H is 135 kilojoules. Since, as per the question, the reaction is exothermic, and if the reaction is exothermic, delta H has to be negative, minus 135 kilojoules per mole. What am I supposed to calculate? The activation energy for the reverse reaction. We are supposed to get the activation energy of backward reaction. Dear students, you should be knowing delta H is nothing but it is EAF minus EAB. This value is equal to minus 135. So I would say EAB would be equal to EAF plus 135. What is EAF? EF is 150. So this is 150 plus 135. The value comes out to be 285 kilojoules. 285 kilojoules per mole is going to be the activation energy for backward reaction. Right? Done? Done, people? Perfectly done. Okay. This is one basic question, which I believe you can easily solve. Arrhenius equation, guys. Ln of K2 divided by K1 is equal to minus EA divided by R, 1 by T1 minus 1 by T2. Right? 1 by T2 minus 1 by T1, sorry. Okay, this is something which can be derived easily. So, nothing to do with this. Let me move on to one more question. Look at this one. The question has been asked in your 2019 NEET. What do you think about this one? For the reaction, activation energy is 0. Okay. We have got a reaction whose activation energy is 0. You know, your Arrhenius equation says K is equal to A, E raised power minus EA divided by RT. Perfect. If activation energy is 0, this term becomes 0. Anything raised power 0 is 1. So, K becomes equal to A. When EA is equal to 0. K is equal to A when EA is equal to 0. So, can I say that reaction whose activation energy would be 0, its rate constant would be temperature independent, as you can see. That particular reaction whose activation energy is 0, its rate constant would be temperature independent. Perfect. Now, since we have got the reaction whose activation energy is 0, that means its rate constant would be temperature independent. You change the temperature, nothing will happen to the rate constant. As per the equation, at temperature 200 Kelvin, rate constant is this much. So, the rate constant at 400 Kelvin, on changing the temperature, nothing happens to rate constant. It will remain the same. It will remain the same. because I'm given with a hypothetical reaction whose activation energy is 0. Yeah? Perfectly done. All right. NEET 2015. The activation energy of the reaction can be determined from the slope of which of the following graphs? From the slope of which of the following graphs? My dear students, you know this is your equation K is equal to A e raised power minus CA by RT, right? If I multiply throughout with a ln, what do I get? I'll be getting ln of K is equal to ln of A minus EA divided by R multiplied by 1 by T. Okay. If I plot ln K along y-axis, 1 by T along x-axis, this becomes my M, sign is minus, and this is C. Y is equal to minus mx plus C. Y is equal to minus mx plus C. So the graph over here between your ln K and 1 by T is going to be something like this. And if you talk about its slope of this particular curve is going to be minus EA divided by R. So can I say activation energy can be depicted from the slope of ln K versus 1 by T? Activation energy can be depicted from the slope of ln K and 1 by T curve, right? It's in front of you. So ln K versus 1 by T is the correct answer. I believe it's clear. All right. What about this one? I'm given with a graph between log K versus 1 by T. Log K versus 1 by T. Few minutes back, I gave you one equation. That was ln K is equal to ln of A minus EA divided by R multiplied by 1 by T. This was my equation. If I convert this equation into logarithmic form, this is going to become like this. Log of K is equal to log of A minus EA divided by 2.303 R multiplied by 1 by T. This is my equation now. If you see carefully, this is my equation now. Now, my dear students, look carefully. I have plotted a graph between log K and 1 by T. I have plotted a graph between log K and 1 by T, right? The equation is of the format y is equal to minus mx plus c, right? So what is the slope of this particular graph? Slope of this particular graph, if you think logically, slope is nothing but that is minus EA divided by 2.303R. This is the slope. And as per the given graph is concerned, slope has to be tan of theta. Slope has to be tan of theta, right? Theta is equal to tan inverse minus 3. So tan theta is going to be minus 3. Simple. Instead of tan theta, I'll be writing minus 3. So I can directly say, people, I can directly say activation energy is equal to P multiplied by 2.303 multiplied by R. This has to be my activation energy. Now the first question is telling us that calculate the activation energy in kilojoules. In kilojoules. So I'll be writing 3 multiplied by 2.303. I'll take the value of R in joules here. That is 8.314 joules per Kelvin per mole. But I have to get the answer in kilojoules. So dividing it with 1000, the answer is going to be in kilojoules per mole. Right? Now in the second question, I'll be doing what? 3 multiplied by 2.303. R value I'll be taking in calories, which is 2 calories per Kelvin per mole. I'll be dividing with 1000. Then it's going to be in kilocalories per mole as well. Right? So both the questions are done and dusted. Correct? I believe you're getting all these things properly. I believe all these things you are getting properly. Right? Am I clear, people? Quickly in the chats. Everybody. Everybody, quickly in the chats. Am I clear? Am I clear, people? Am I clear? Amazing. Amazing. Let's move on then to few more. Okay. Can you solve this one? Similar sort of question I've shown few minutes back only. Few minutes back I've shown you the similar sort of question. Will you be able to solve this? Will you be able to solve this one? Quick. Everybody. Quickly, guys. People are saying option B. Are you sure? Are you sure? Think about it. Think about it, guys. See, few minutes back, I gave you an equation that was your T half is directly proportional to A naught raised power 1 minus n. And from this particular equation, we got one thing. T half of 1 divided by your T half of second is nothing but that is A naught 1 divided by A naught 2 whole raised power 1 minus n, where n is the order of the reaction. This was the equation which I gave you a few minutes back. Now, consider this as T half 1, consider this as T half 2. So it's going to be 4 by 2 is equal to A naught 1, A naught 2. So it is 50 divided by 100 whole raised power what? 1 minus n. So this is going to be 2 is equal to 1 by 2 whole raised power 1 minus n. So 2 is equal to 2 raised power n minus 1, or I can say n minus 1 has to be equal to 1, which is telling you that n is equal to 2. So order of the reaction is 2. I'm solving the same question second time. It is the same question. It's 100% same to same, right? It is 100% same to same question, which I believe you can easily solve from now on. Okay? All right, let me find some more questions which are slightly different. The above reaction is of zero order. Half-life of the reaction is this. The time taken for the concentration of A to reduce to 1/4. Okay, give it a try. Give this question a try. I'm also seeing these slides for the first time. I mean, I've seen the questions but not solved them before. Quick. It's a simple question, guys. It is a simple question. The reaction is like this. A gives B. All right, this is something that's given to me. The above reaction follows the zero order kinetics. The reaction follows the zero order kinetics. Half-life of the reaction is 50 minutes. Okay, let me write it somewhere here. Half-life is equal to how much? 50 minutes. Perfect. Half-life is equal to 50 minutes. The time taken for the concentration of A to reduce to 1/4 of its initial. Okay. The time, half-life of the reaction is 50 minutes. Okay. The time taken for the concentration of A to reduce to 1/4. Isn't the rate constant given here? Okay, rate constant will be getting from here. T half is nothing but that is A naught divided by 2K. So A naught divided by 2K is equal to 50. A naught divided by 2K is equal to 50. So A value, K value here is going to be A naught divided by 100. This is your K. Is the value of initial concentration given anywhere? Half-life of the reaction is 50. The time taken for the concentration of A to reduce to 1/4 of its nearest value. Okay, let's keep K value as such. Let's see what happens. Okay, the reaction is A gives B. Initially at time t is equal to 0, the concentration of reactant, for example, is A naught. This is 0. We have to check at what time. At what time the concentration of reactant will reduce to 1/4 of its initial value. Concentration of reactant will reduce to 1/4 of its initial value. So at what time the concentration of reactant has to be A naught by 4? At what time the concentration of reactant has to be A naught divided by 4? Okay. So, my dear students, it's going to be, since it's zero order reaction, right? It's zero order reaction. AT is equal to A naught minus KT. Perfect. What is AT? AT is nothing that is A naught by 4 is equal to A naught minus K is how much? That's A naught divided by 100 multiplied by T. So A naught, A naught, A naught, everywhere cancels out. So 1 by 4 is equal to 1 minus T divided by 100. Perfect. So now it's just a matter of calculation. If you try to solve it here, it's going to be T divided by 100 is equal to 1 minus 1 by 4. 1 minus 1 by 4 is 3 by 4. So it's going to be T is equal to 300 divided by 4. So 300 divided by 4 is how much? 75. The time is in minutes, right? So 75 is the correct answer. Correct, people? 75 minutes is the correct answer. I believe it's clear. I believe even this particular question is clear to you. Okay. All right. What about this one? It's again a simple basic question, I must say. For the first order reaction, A gives B. Half-life is We have got a first order reaction whose half-life is given to us as how much? It is 30 minutes. Okay. Time taken to complete 75%. You know, T 75% is equal to 2 times the half-life in case of first order kinetics. So 2 into 30 is 60 minutes. Right? This sort of equation, it should be solved quickly because it's a basic one. It's a basic one. I hope I'm clear with this. And if I'm clear with this, can you try to solve this one? The rate constant of the first order reaction is given by the following equation. Equation is ln of K is equal to 33.24 minus 2 into 10 raised power 4, 2 into 10 raised power 4 divided by T, Kelvin. What do we have to calculate? The activation energy of the reaction is given by. Okay, we have to calculate activation energy. My dear students, if you look perfectly here, this is my equation which is given. We know one more similar equation. We know one equation of the similar format. Ln of K is equal to ln of A minus EA divided by R 1 divided by T. Okay. If you compare these two equations, 1 by T, 1 by T, ln K, that means ln A is this and EA divided by R is how much? By comparing the two equations, I got to know EA divided by R is nothing but that is 2 into 10 raised power 4. So your EA would be equal to 2 into 10 raised power 4 multiplied by R. We have to take the value of R as how much? 8.314. The answer has to be in kilojoules. Since I have taken 8.314 joules per Kelvin per mole, so I'll be dividing with 1000 as well. Then finally, the answer is going to be in kilojoules per mole. Right? This sort of equation can also be asked. I hope I'm clear with this. I hope I am clear with this particular question as well. Okay? So I hope with this, if a question comes from the chapter Chemical Kinetics, you should be able to solve that question. If yes, let me know once in the chats quickly, then I'll be jumping into the electrochemistry chapter. Quick, people. Quickly. Quickly, guys. Quickly, everyone. Do you want to take a 5-minute break? I'm going to have my dinner after this session. Okay, but I can only give you a break if you come back, all. If all of you come back. Are you promising that? Say yes or no in the chats, quick. Are you promising that all of you will be back on time? Because otherwise it's going to be no fun in solving alone, you know, if people will be missing. All right, it's 9:22. Let me give the break for 15 minutes. Okay, so that you refresh and come back. So, break till it's let's make it directly as 9:40. At 9:40, I would want everyone to be back. Okay, if you want to have tea, coffee, dinner, whatever you would want to have, just have it in this particular time. Okay. Okay, but be back. Be back. I'll be waiting for you. I'll see you at the given time. Is everyone back? Is everyone back? Yeah. What's up? What's up? What's up? How are you? All right, guys, the questions which I discussed from the chapter Kinetics, are they like very clear to you? Are they clear? Are they clear? Just tell me that. No, I did not have my dinner yet. I'll have it after the session. Let the session end and then I'll be having my dinner. I just had a cup of tea. So have you revised electrochemistry chapter? Yes or no in the chats? Have you revised the electrochemistry chapter? Have you revised the electrochemistry chapter? Let me know in the chats quickly. 11th physical chemistry also I'll be doing. Don't worry. All right. So I think people have come. So let's get going. Let's get started with one more important chapter from which you get 3 questions. I hope you know that. From this particular chapter, you get 3 questions. So let's start the session with one simple confidence booster. Tell me the answer of this question, guys. Simple confidence booster this is. Galvanic or voltaic cell is a device used to convert chemical energy produced in dash reaction into dash energy. I want everyone to type the answer in the chats quickly. I want the chats to run because this is the easiest among all the questions. What does a galvanic cell do? A galvanic cell converts chemical energy into electrical energy. That chemical energy which is produced in the redox reaction into what? Into the electrical energy, right? So yes, galvanic cell or voltaic cell is a device used to convert chemical energy produced in the redox reaction into what? Into the electrical energy. The basic question this was, okay? You are supposed to be careful here. You are supposed to read the complete sentence. I know a lot of students would have mentioned this as the answer. Okay? Not this, sorry. Yeah, a lot of students would have given this as the answer without even thinking. So it's option C basically, which is the correct answer of the question. Okay. In your Daniel cell, what happens? Zinc rod behaves like the anode, copper rod as the cathode, zinc rod as cathode, copper as anode. Zinc rod is represented by positive electrode, copper rod is represented by negative electrode. Quickly, if you talk about your Daniel cell, my dear students, if you remember the construction of your Daniel cell, in the Daniel cell, if this is the salt bridge, on the left, you have got anode, which is your zinc, right? On the right side, you have got cathode, which is your copper electrode. I hope you remember this. So what is going to be the answer of this question? Zinc rod behaves like the anode and copper, it acts as the cathode. A simple basic question this. Guys, I want you to write the answers in the chats. Okay? I want the chats to run continuously. Chats should not stop. Okay? Otherwise, there is no fun in doing these questions. At least I should feel that you guys are active in the chats. So please be active in the chats. Write your answers. Don't think whether your answers will be wrong, right. Do not think about the consequences, right? Perfect. There is no one superior to you here. Everybody is same, whosoever is watching this video right now. Perfect. Do not think what others will think of you. They do not know who you are. Don't worry. Okay? If it is wrong also, I'm here to correct it. So I want you guys to be active in the chats continuously. Moving on. Tell me what is the answer of this question. Quick. The potential difference between the two electrodes of the galvanic cell. The potential difference between the two electrodes in case of the galvanic cell. What do you call that potential difference as? The maximum potential difference between the electrodes when the cell is not in use, that is EMF, right? Other than that, what do you have? You have cell voltage, cell potential. So option C is the one that's correct. See, a lot of students did a mistake. They wrote electrode potential as the answer. What is electrode potential? Electrode potential is the potential difference that gets created between the rod and the solution. That gets created between the rod and the solution. Is not talking about that potential difference. Is talking about the potential difference that gets created between two electrodes in a galvanic cell. Right? So it has to be your cell potential. Okay. Tell me the answer of this question. Again, a simple one this is. Again, a simple one this is. In galvanic cell, anode is on left hand side and is positively charged. Anodic rod. Which charge is there on the anodic rod? On the anodic rod, electrons they get accumulated on the anodic rod, due to which anodic rod gets negative. So first cannot be the answer. Anode is on left hand side and is negative electrode. Cathode is on right side and is positively charged electrode. It is positive electrode. Option D is the one that's correct. Option D is the one that's correct. Now tell me the answer of this question. The potential developed between the electrode and the electrolyte. Now you should answer this question properly. There should be no mistake here. There should be no mistake here. I'm looking at your chats. There should be no mistake here in this question. The potential difference that gets created between rod and the solution. What do you call that potential difference as? Electrode potential. Right? Electrode potential. Amazing. Amazing, guys. Tell me the answer of this question. The electrochemical cell stops working after some time. Electrochemical cell, it stops working after some time. Why is that? Why is that? Why is that? Why is that? Tell me the answer in the chats quickly. The question, my dear students, is pretty much simple. An electrochemical cell stops working after some time. You have to let me know the reason of this question. What is the reason? The first statement says electrode potential of both the electrodes becomes zero. Is that the answer? No. Electrode potential of both the electrodes becomes equal. If you remember your equilibrium condition, at equilibrium, what happens? The electrode potential of both the electrodes becomes equal, due to which potential difference becomes zero. Right? So, this is the correct answer. Electrode potential of both the electrodes, it becomes equal after some time, due to which there will be no potential difference. And if there is no potential difference, no current generation. Right? Perfect. 4 statements I have mentioned here. Tell me which all statements are correct. Quick, everybody. Which of the following statements are correct for the galvanic cell? Reduction at cathode, that's correct. Oxidation at anode, correct statement. Reduction at anode, oxidation at cathode, wrong. Electrons flow from anode to cathode, yes. Electrons flow from anode to cathode. Current is from cathode to anode. Electrons flow from, this is wrong. So 1 and 3. So which one? Someone is saying B for biology. It's not B, it's D. D for dog. Yeah? D for donkey. The ones who are giving B option here. Okay, D for doctor. All right. Agreed. D for doctor. D for dumb. And what else? What else? D for Dawn, Wasima. Do I look like a Dawn to you? I don't look like a Dawn. I am a Dawn. Yeah? All right. Have a look on the next one. Tell me the answer of this particular question. The question is, when the salt bridge is removed, when you remove the salt bridge, what happens? Tell me. When we remove the salt bridge, what happens? The voltage does not change. The voltage increases to maximum, decreases to half the value, drops to 0. Quick. Everyone. Quick, people. Everyone. Yeah? Perfectly done. When salt bridge is removed, voltage drops to 0 and it stops working after some time. Okay? All right. Tell me the answer of this question. These are all theoretical questions which can be asked in assertion, reasoning, etc., right? What do you think? Quick. What do you think about this one? Quickly, people. It's again a simple one. It's again a simple one. In galvanic cell, which of the following statements are correct regarding salt bridge? I hope you know what salt bridge is. Salt bridge is used to complete the circuit, internal circuit, to maintain the electrical neutrality. Yes. For the smooth flow of current. Absolutely. So, option D is the one that's correct. All are correct. All are correct. Perfecto. Tell me the answer of this particular question. A standard hydrogen electrode has a 0 potential. Standard hydrogen electrode has a 0 potential. Why? What is the logic? It is assumed, right? We assume that your standard hydrogen electrode, it has got the 0 potential. We assume that. That's something which we assume. Okay, we do not calculate it from somewhere. It is the assumption from our side, right? So option D. Option D. Perfect. Calculate E0 for the given cell. We are given the cell. This is the salt bridge. On the left side, we have zinc electrode. On the right side, we have got copper electrode. E0 values are given. What are we supposed to calculate? We are supposed to calculate E0 cell. My dear students, do you remember E0 cell is nothing but E0 cathode minus E0 anode? And in this particular equation, what do we exactly use? This is your SRP of cathode and this is your SRP of anode. Okay. Now, cathode is copper. Cathode is copper. What is the SRP of cathode? What is the SRP of copper? If you look at this value, copper here is in 0 oxidation state, 0 to plus 2. Increase in the oxidation state, 0 to plus 2 means increase. Increase means oxidation. That means this is SOP of copper. But what do I need? I need SRP of copper. SRP of copper will be, change the sign. So it is plus 0.34 volts. Look at this one, 0 to plus 2, increase, oxidation. This is also SOP. What do I need? I need SRP. SRP will be minus 0.76 volts. Now it's done and dusted. SRP of cathode. SRP of cathode is 0.34 minus SRP of anode. SRP of anode is minus 0.76. The value overall is going to be 1.1 volt. This is going to be your E0 cell. Right? Everyone has given the answer. Amazing. Good job. Moving on to the next one. Moving on to the next one. Look at this one, people. You should be in a position to solve this one as well. The standard electrode potentials. Sn plus 4 to Sn plus 2. Plus 4 to plus 2. Decrease. Reduction. So SRP. This is the SRP value of the electrode. 0.15 volts. Let me write it. This is the SRP of the electrode. We have got one more electrode, Cr plus 3, Cr plus 3 to 0, decrease, reduction. So this is also the SRP. So SRP of this chromium electrode is minus 0.74 volts. I've got two electrodes. I've got two electrodes here. I'm connecting these two electrodes externally and internally. I'll be getting a complete cell. We have to calculate E naught for that complete cell, which is nothing but E naught cathode minus E naught anode. First of all, among these two electrodes, which one would be cathode, which one would be anode? Look carefully. Look carefully, guys. Both are SRP values. This SRP is more. More the SRP, more the SRP, more the tendency to undergo reduction. More the SRP, more the tendency to undergo reduction. And reduction takes place at cathode. So this is your cathode, this is your anode. So E naught of cathode 0.15, E naught of anode minus 0.74. When you solve this, how much it comes out to be? 0.89 volts. Option A is the one that's correct. Yes? A for apple, huh? Okay. Look at this question. A simple basic one this is. What do you think? You are given with a Daniell cell. If the concentration of both zinc dipositive and copper dipositive ions are doubled, what happens to EMF? What happens to EMF? Think over it. Well, people, there is not much to think about this particular question. It's a simple one. How exactly to deal with this? Have a look. This is the salt bridge. On this left side, we have got anode. At anode, what happens? Oxidation. So zinc is getting converted into zinc dipositive. So reaction is going to be zinc getting converted into zinc dipositive plus 2 electrons. This is the reaction at anode. Similarly, if I ask you what is going to be the reaction at cathode? At cathode, copper dipositive getting converted into copper. So reaction is pretty much simple. Copper dipositive would be gaining 2 electrons, getting converted into copper solid. Electrons are balanced, so I can directly add these two reactions. When I add these reactions, my net reaction is going to be zinc solid plus copper dipositive aqueous. It gives zinc dipositive aqueous plus what? Plus copper solid. And these two electrons will be cancelled out. So I would say N value here is 2. Perfect. This is my net reaction. If this is my net reaction, can't we write QC value? What is QC? QC is going to be concentration of zinc dipositive raised by stoichiometric coefficient 1 divided by concentration of copper dipositive raised by stoichiometric coefficient 1. I wrote the QC value. Okay. Now, my dear students, just understand. Write the Nernst equation. Nernst equation says that E cell is equal to E naught cell minus 0.0591 divided by N log of QC. QC here is concentration of zinc dipositive divided by concentration of Cu dipositive. This is your Nernst equation. Now the question says, if the concentration of zinc dipositive as well as copper dipositive, both are doubled. If both are doubled, what happens? Nothing. If this is 2 times, this is 2 times. 2 gets cancelled. Nothing happens to E cell. E cell remains the same. Nothing is happening to that. Yeah? C4? C for what? Clever, huh? Cringe people. C for cringe people, is that? Wow, someone is saying C for cardiologist. He has already done his MD and stuff, huh? Without doing MBBS. Nice. Of course, C for chemistry. Chalo, one more. Tell me the answer of this question quick. Tell me the answer of this one quick. Tell me the answer of this question quick. Everybody. If you look at this particular question, we are given the cell. All right, we have to get the QC value. Pretty much simple. How exactly? First of all, write the reaction at anode. At anode, zinc getting converted into zinc dipositive. So the reaction at anode is zinc solid gives zinc dipositive aqueous plus 2 electrons. This is your reaction at anode. Now, what is the reaction at cathode? At cathode, Ag positive into Ag. So I would say at cathode, Ag positive aqueous would be gaining 1 electron, getting converted into what? Ag solid. Now, my dear students, you cannot directly add these two reactions. Why? Because the electrons are not balanced yet. Electrons are not balanced yet. We have to balance the electrons. Multiply this reaction by number 2. So this is 2 times, this is 2 times, this is 2 times. Now the electrons are balanced. If I add these two reactions, what do I get? When I add these two reactions, I'll be getting something like this. Zinc solid plus 2 times Ag positive aqueous. It gives zinc di positive aqueous plus 2 times Ag solid. Now this is your net reaction. If this is the net reaction, I can write the QC. And how do you write the QC? Start with this. Concentration of zinc di positive raised power stoichiometric coefficient. This is solid. I've got nothing to do with it. Divided by this is solid. Nothing to do with it. This is going to be concentration of Ag positive raised power stoichiometric coefficient 2. Now, my dear students, concentration of zinc di positive is given 10 raised power minus 2. So 10 raised power minus 2 divided by concentration of Ag positive is given. That is 1.25 per square. And we are done. Let me tell you, this sort of a calculation won't be asked in the exam. Okay? Calculation part is going to be easy. Concept might be the same. Calculation part is going to be easy. Concept might be the same. Okay? Moving on. Moving on to one more. See, this question, similar type of question I have solved a few minutes back. I believe you can easily solve this one as well. Right? Reduction potentials of 2 electrodes are given. You have to calculate E naught cell. E naught cathode minus E naught anode. I believe you can do this. I believe you can do this. Is that? Say yes or no in the chats. Okay, tell me the answer. I'm waiting for you. Tell me the answer. Tell me the answer quick. Tell me the answer quick. This is SRP of cathode. Cathode is your copper because copper is undergoing reduction. So SRP of copper is 0.34 minus SRP of magnesium is minus 2.37. So the value will be 2.71 plus volts. See. Perfect. Moving on. Moving on, moving on. All right, let me see how you are going to solve this question. Kindly do ionic equilibrium. Ionic equilibrium I have taught in detail on this channel. Have you not gone through? Guys, just a second, let me show them that we have. See, when you go to Unacademy NEET English channel, there is a playlist. Click on playlist, okay? Once you click on playlist, drag it down. Here there is a Game of NEET 2.0 playlist, view playlist. Once you click on this view playlist, this is your mole concept. Okay, this is your mole concept. These are top 100 questions of mole concept. Chemical bonding complete. Top 100 questions of chemical bonding. Solution chapter complete. Where are the top 100 questions of solution? Not done yet. Okay, redox reaction, complete chapter. Electrochemistry, broken down into 2 parts, complete chapter. Thermodynamics, complete chapter. Thermochemistry, complete chapter. Top 100 questions of thermodynamics, complete. Chemical equilibrium, in 7 hours it's completed. Ionic equilibrium in 8 hours, 12 minutes. This is your ionic equilibrium. Someone wanted to check which ad is this coming. Join free workshop. Are you struggling with your JEE NEET preparation? No, they're not struggling. Thank you so much. Okay. So this is your ionic equilibrium, guys. The ones who wanted to see the ionic equilibrium, this is the complete chapter, like taught in very much detail. All the question patterns done. Okay, you can check it out here. And similarly, there are a lot of chapters which you can see: basics of organic chemistry, GOC, top 100 questions of GOC, chemical kinetics complete chapter, atomic structure complete chapter. Then comes Yavarser, electrostatics, periodic classification, breathing exchange of gases, capacitors. Like these are 80 chapters, guys. All are given in the detailed format. This was your Game of NEET 2.0. Okay? So the ones who wanted to consult, you can check this out. Atomic structure is also there. All right, I'm moving on. Perfect. Look at this particular question now. Let's get back. Let's get back to the business. Tell me, people. A solution containing H positive and D positive ions is in equilibrium with the mixture of H2 and D2 gases, okay, at 25 degrees centigrade. If the partial pressure of both the gases are 1 atm, find the ratio of concentration of B positive, H positive. Given E, D positive gives D2 is equal to this. It's a good question. Try to understand how exactly we are supposed to solve this question. Hey guys, as per the question, we have got two electrodes. Understand properly. Imagine this is your one container. This is one more container. In this particular container, there are H positive ions, and this is the rod on which H2 gas is adsorbed. The rod carries H2 gas. Similarly, here you have got D positive ions, and here you have got D2 gas, which is adsorbed on this rod. Well, the pressure of both these gases, H2 and D2, that is kept as how much? That's kept as 1 atm. Pressure of H2 gas here, pressure of D2 gas here, 1 atm. Now, as per the question, guys, let's say you have connected them externally as well as internally. So you have got a complete cell. This is your complete cell. In this complete cell, let's assume this is your anode, this is your cathode. Or let's not assume things. See, if you look here, D positive, D2. So plus 1 to 0. Plus 1 to 0 means? Plus 1 to 0 means decrease, reduction. So this is SRP. This is your SRP. This is SRP. SRP of deuterium electrode is minus 0.003 volts. This is SRP of deuterium electrode. And SRP of hydrogen electrode is going to be 0. So on one side, you have got E naught of H positive giving H2, that is 0 volt. And on another side, you have got E naught of D positive gives D2. That is equal to minus 0.003 volt. So which one has got more reduction potential? Hydrogen electrode. So one having more reduction potential behaves like cathode, and this is going to be anode. So basically I have to reverse the setup. Your deuterium electrode is behaving like anode, and your hydrogen electrode is behaving like cathode. Deuterium electrode is behaving like anode. Okay? And once we got to know which one is anode, which one is cathode, now the things are becoming easy. How exactly I'm going to do after this? Have a look. First of all, let me talk about the reaction taking place at anode. Anode means deuterium. At anode, oxidation takes place. So reaction has to be D2 gas. It gives what? 2 times D positive aqueous plus what? Plus 2 electrons. This is the reaction at anode. Now, what would be the reaction at cathode? Cathode is your hydrogen electrode, and at cathode reduction takes place. So at cathode, the reaction is going to be 2 times H positive aqueous plus 2 electrons. It gives H2 gas. This is the reaction at cathode. You got reaction at anode as well as reaction at cathode. If you got reaction at anode and cathode, just add them up. My net reaction is going to be D2 gas plus 2 times H positive aqueous. What does it give me? 2 times D positive aqueous plus what? Plus H2 gas. This is my net reaction. If this is my net reaction, what is the value of N then? N value here is 2, because 2 electrons got cancelled. N is 2. If N is 2, I can write QC expression as well. It's going to be concentration of D positive raised by stoichiometric coefficient. Partial pressure of H2 is 1 divided by. It's going to be concentration of H positive raised by 2, and partial pressure of D2 is also 1 given in the question. So this is your QC expression. Okay? This is your QC expression. Now if I ask you what about E naught cell? E naught cell would be equal to E naught cathode minus E naught anode. This is cathode. E naught cathode is 0 minus E naught anode. E naught anode. This is SRP of anode, which is minus 0.003. The overall value comes out to be 0.003 volts. Okay, this E naught cell. Perfect. What do I need? I need this particular value. Now see what I'll be doing. Use the Nernst equation. Just a second. As per your Nernst equation, I would say E cell is equal to E naught cell minus 0.0591 divided by N, and it's going to be log of QC. In the question, is anywhere mentioned some equilibrium condition, equilibrium state? Something related to equilibrium is mentioned. And when the cell is at equilibrium, What about E cell? At that point of time, E cell is 0. If E cell is 0, I can say E naught cell is equal to 0.0591 divided by n log of, instead of QC, I'll write equilibrium constant KEQ. Okay. So I can simply say like this, log of KEQ is equal to n values to E naught cell is 0.003. That means it will be 0.006 divided by 0.0591. I can use 0.06 instead of this, right? Perfect. I hope this calculation till here is easy. Now I'm erasing this part. I am erasing this particular part. I hope till here everything is clear. Now, if everything is clear till here, now what do I do after this? See guys, I'll write log of KEQ. KEQ was your QC. QC was, what was QC? I forgot. Was it concentration of H positive square divided by D positive square? You have got deuterium as anode. If it is as anode, so it becomes D positive. So it should have been like this. D positive divided by H positive. Was this QC expression, guys? Just tell me in the chats quick. Was this D by H? I think this was. Yeah, okay, perfect. Now, 0.006 divided by 0.06. How much it comes out be? How much it comes out be? Quickly. How much? 10 raised per? 10 raised per what? Can't you do the calculation also? 10 raised per -1. Okay? 10 raised per -1. So 0.1. Okay? Now, are we done? Are we done with this question now? Are we done with this question now? What exactly we were supposed to calculate? We were supposed to calculate D positive divided by H positive. And you got that. You got the ratio. You got the ratio. Right, people? Perfect, perfect, perfect. I hope you got to know how do we deal with these sort of questions. And the final answer after solving will be 1.12. By the way, this sort of a calculation again won't be asked in the exam. Concept wise is going to be same. But this sort of a calculation won't be asked. Because otherwise you'll get stuck here, right? This is going to be D positive, H positive whole square. It becomes 2 comes in the beginning. It becomes 10 raised power -1 divided by 2, right? So it becomes 1 by 10, 1 by 20, 1 by 20, right? So it becomes a bit cumbersome calculation. Or let's check it out. Concentration of D positive divided by concentration of H positive whole square, right? I can write it like this, whole square. And this is log here. This is 0.1. So 2 comes to the front, 2 comes to the front, 2 comes to the front here, and that 2 goes here. This is 0.1 divided by 2. This becomes 0.1 divided by 2, right? Which comes out to be 0.05. Perfect. So you got log of D positive concentration divided by H positive concentration as 0.05. So it is D positive divided by H positive concentration. This is going to be NT log of 0.05. NT log of 0.05. This particular term should be given in the question. Okay, then only you can solve. I hope you got to know how to deal with this sort of a question. Anyways, I'm moving ahead so that you get used to these sort of questions. Just a second. Okay, just one more question. The measured voltage for the reaction with the indicated concentrations is 1.5. Calculate E naught. Reaction is given. Reaction is given. Someone is saying option 4. Of course, it's mentioned here as option 4. Wow. So brainy you are. Okay, first of all, if I write the QC expression here, QC is going to be concentration of Cr tri positive raised power 1 divided by concentration of Ag positive raised power 3. What is the concentration of Cr tri positive? It is 0.3. Ag positive concentration 0.1 whole raised power 0.1 whole raised power 3. So it is something like this. 0.3 I can write as 3 into 10 raised power minus 1 divided by. This becomes 10 raised power minus 3. 10 raised power minus 3 comes up. So finally it becomes 300. Finally it becomes 300. This is QC. I got QC. What do I need? As per the question, E cell value is given. How much? E cell value is 1.5. Okay. What about the N value? 0 to plus 3. N value here is 3. N value here is 3. N value also you know. Now you can use Nernst. E cell is equal to E naught cell minus 0.0591 divided by N and the log of QC. If you look at the question carefully, QC value you got, N value you got, E cell you have. So from here you can easily calculate E naught cell. Got it? Got it, people? So it is now the matter of calculation only. I'm again repeating, calculation part is going to be easy in the question. Calculation part is going to be easy in the question. Anyways, this is a simple calculation only. It's not difficult. This is QC. QC is 300. 300 means 3 into 10 raised power 2. Now you can solve this and easily get the answer. All right, I'm moving on. For the cell reaction involving 2 electron change. For the cell reaction involving 2 electron change. The standard EMF of the cell. The standard EMF of the cell is given to me. What do I have to calculate? I have to calculate equilibrium constant. And when the cell is at equilibrium, you already know E cell is equal to 0. When the cell is at equilibrium, E cell is 0. And when E cell is 0, you can write Nernst equation like this. E naught cell is equal to 0.0591 divided by N log of KEQ. Now, if you look carefully, E naught cell is given. N value we already know, right? So from this particular equation, equilibrium constant KEQ can be calculated. Simple basic equation this is, right? Calculation part is going to be easy in the question. I'm again repeating the same thing. Don't worry about the calculation here. Don't worry about the calculation here. Tell me the answer of this one. Tell me the answer of this particular question. The nature of curve between E naught cell versus the log of equilibrium constant. E naught cell versus equilibrium constant. So first of all, they are asking about the graph between E naught cell and equilibrium constant. So I'm assuming cell is at equilibrium. And when cell is at equilibrium, you know, at that time E naught cell is equal to 0.0591 divided by N log of KEQ. Let's assume E naught cell is plotted along y-axis. A log of KEQ is plotted along x-axis. This becomes your M. Y is equal to mx, means straight line. Y is equal to mx means straight line, right? I believe this is also clear. I believe this is also clear. Right? Tell me the answer of this one. In the Nernst equation, E is equal to E naught minus RT divided by NF ln Q indicates that Q will be equal to equilibrium constant when Q is equal to K. Q is equal to K. Reaction quotient becomes equal to equilibrium constant when? When the cell is at equilibrium. When the cell is at equilibrium. And when the cell is at equilibrium, E cell value at that time is 0. Right? Clear? I hope it's done. All right. What about this one? What about this one? The oxidation potential of the hydrogen electrode. Oxidation potential of the hydrogen electrode. This is your hydrogen electrode. You have to check its oxidation potential. pH of the solution is 10 and partial pressure of H2 is given me as 1 atm. See, how do I tackle this sort of equation? It's simple again. So guys, first of all, we have to talk about oxidation potential. Oxidation takes place at anode. Let me assume that this hydrogen electrode is behaving like anode. And when hydrogen electrode behaves like anode, what happens? Oxidation. So I would say the reaction is going to be H2 gas gives 2 times H positive aqueous, and with this you get 2 electrons. So N value first of all here is 2. If I get the QC is going to be concentration of H positive raised power 2 divided by partial pressure of H2 gas. Right? Perfect. Partial pressure of H2 gas is given to me as 1. So let me remove this part. Let me keep it as such. Now, if I use the Nernst equation says that oxidation potential of the half cell is equal to standard oxidation potential minus 0.0591 divided by N. It's going to be log of QC. This is your expression first of all. Now, after writing this particular expression, the oxidation potential of the hydrogen electrode, I have to calculate. EOX I have to calculate. Oxidation potential of the hydrogen electrode. This is SOP of hydrogen electrode. And standard oxidation potential as well as standard reduction potential of hydrogen electrode is 0. So this is minus 0.0591. N value here is 2. Log of QC. QC is concentration of H positive raised power 2. So this is going to be EOX is equal to minus 0.0591 divided by 2. This will be 2 times log of H positive concentration. This 2 got cancelled. So I can say EOX is equal to minus 0.0591 and this is log of H positive. Now this minus log of H positive is what you call as pH. So this is 0.0591 multiplied by pH of the solution. This is the final expression. So this is your oxidation potential of the hydrogen electrode, which you were supposed to calculate. Now, my dear students, as per the question, pH is given to me as 10. If this is 10, this multiplied by this would be how much? 0.591 volts. You can directly remember this expression. And if you have watched the marathon, guys, in the marathon, I've already given you this expression. I thought you won't be remembering it right now. So that's why I derived this particular expression again. Oxidation potential of the hydrogen electrode when the partial pressure is 1 bar or 1 atm is 0.0591 into pH of solution. Similarly, reduction potential of the hydrogen electrode will be minus times 0.0591 into pH of solution. I hope I'm clear with this. Theoretical question this is. This at least you should know. Which of the following conditions salt bridge is not required? When do you not require the salt bridge? Salt bridge is required when you have got two different electrolytic solutions, right? When you have got two electrolytic solutions kept in two different containers. At that time you require the salt bridge. If there is only one solution like this and you have got a semi-permeable membrane here, this one electrode for example, this one more, here they are connected. Do you require salt bridge here for the cell to work? You don't require a salt bridge here, though liquid junction potential gets arised here. But I'm not talking about liquid junction potential, though liquid junction potential will arise here. Okay, but cell will work. So option D is the one that's correct. Okay. As per the question, you are given the cell reaction. Cell reaction is like this. Copper plus 2 times Ag positive gives what? Copper di positive plus Ag. You have to represent this particular cell. A simple basic question. This is 0. This is plus 2. 0 to plus 2 increase oxidation. Oxidation takes place at anode. So this is your anode. Automatically this becomes my cathode. How do I represent it now? This is salt bridge. On the left side anode. At anode your copper solid is getting converted into copper di positive aqueous. At cathode reduction takes place. Ag positive aqueous is getting converted into what? Ag solid. Right? This is the cell representation. Correct? This is your cell representation. Simple? All right. Moving on. All right. This is the cell. Which of the following is correct? Which of the following is correct? First of all, let me write the cell reaction. Copper into copper di positive, Ag positive into Ag. So reaction at anode. At anode, your copper solid is getting converted into copper dye positive aqueous plus 2 electrons. This is the reaction at anode. What about cathode? At cathode, I would say Ag positive is gaining 1 electron, getting converted into Ag. Are the electrons balanced? No. Let's balance the electrons. So 2 times, 2 times, 2 times. At these two reactions, I would say copper solid plus 2 times Ag positive aqueous. It gives copper dye positive aqueous plus 2 times Ag solid. This is my net reaction. This is my net reaction. Now, my dear students, we are done almost. See, copper is getting converted into copper dye positive. Increase in oxidation state. So I would say this is undergoing oxidation. The one that undergoes oxidation is what you call as reducing agent. If this is the reducing agent, this is going to be oxidizing agent. So one part is done. Overall cell reaction you have written. This overall cell reaction. Okay. Copper is cathode and Ag is anode. See, copper is undergoing oxidation. Oxidation takes place at anode. So this is your anode and this automatically is your cathode. Now you can check your answers. You can check your answers. First one says copper is reducing agent. Is copper reducing agent? Copper is undergoing oxidation, so reducing agent. Yes, okay, that's correct. So one is correct. Overall cell reaction. Copper solid plus 2 times Ag positive gives copper dye positive plus 2 times Ag solid. Yes, second statement is also correct. Second is also correct. So that means option D is the one which is correct. I believe I'm clear with this. All right. Tell me the answer of this one. Standard reduction potentials. SRP values are given. SRP values are given. More the SRP, more is the tendency to undergo reduction. More tendency to undergo reduction means better oxidizing agent. Better oxidizing agent means more oxidizing power. Now, anything can be done. You have to check which of the following is the strongest oxidizing agent. Strongest oxidizing agent is the one which has got more SRP. Now, which one has got more SRP? Check the maximum value of SRP. Maximum value of SRP here is minus 2.37. It's for Li positive, right? That's for Li positive. Did you write? Oh, did I make any mistake here? A lot of people are saying last one. Okay, minus 2.37 is for Mg dye positive. Sorry. Minus 2.37 is for Mg dye positive. So option D. My bad. Okay. All right. Now you have started to correct me, huh? Good, good, good. This will be remembered. This is a similar sort of question, so no need to solve this. I'll go to this one. What do you think about this one? So you corrected me once, huh? I'll remember this. Let me give you a tough question after this. Yeah. It will be remembered. You corrected me once. You know Rutherford? Rutherford's experiment you study, right? Rutherford was Thomson's student. Rutherford was Thomson's student. You know Thomson gave the atomic model? When Thomson gave the atomic model, after that his student Rutherford was the one who said Thomson's model is incorrect. So this is what students do. This is what students do. Yeah. Majority is coming up with option B. Let's check it out. Reducing power, huh? Reducing power. See. First of all, more the SOP, more the tendency to undergo oxidation, more the tendency to undergo oxidation, better the reducing agent, more the reducing power. We have to check reducing power. So SOP and reducing power, they are directly proportional. Now all of these are SRPs. So convert these SRPs into SOPs. Just reverse their sign. This will be plus 0.76, plus 2.36, plus 2.87, plus 0.25. So which has got maximum SOP? I would say calcium has got maximum SOP. Calcium has got maximum SOP. If calcium has got maximum SOP, right, it has got more tendency to undergo oxidation, better reducing agent, more reducing power. So it's going to be calcium which will be having maximum. Calcium will be having maximum reducing power. After calcium, it's going to be, if this is plus 2.87, this will be plus 2.36. After calcium, it's going to be magnesium, right? So option B, you all are correct. Okay. All right. Tell me the answer of this one. Tell me the answer of this particular question, quick. Are you fasting? Yes, I was fasting the whole day. Quickly, guys. What do you think is the answer of this one? It's a pretty much simple question, I believe. Majority is coming up with option B and D. B and D, yeah? B and D. Let me check it out. So basically, if you look at this particular reaction, zinc is undergoing oxidation. So this is your anode, this is your cathode. What do I have to calculate? E naught cell. E naught cell is nothing but E naught cathode minus E naught anode. So SRP of cathode, SRP of iron. This is SOP of iron. What do I need? SRP minus 0.41 minus SRP of anode. SRP of anode. Zinc is your anode. This is SOP of anode. I need SRP. So reverse the sign. Minus 0.76. The final answer will be plus 0.35 volts. Right? It has to be option B. Simple again. Yes, perfectly done. Option B is correct. Guys, see. This reaction, if you look at this particular reaction, loss of electrons. Loss of electrons means oxidation. So this is SOP here. Even this, loss of electrons. This is also SOP. I converted these SOPs first of all into SRPs. Then I solved the question. I'm moving on to one more. These questions are done. Look at this one. Can you solve this one? Can you solve this one? Check it out. What do we have to calculate? We have to calculate oxidation potential. We have to calculate the oxidation potential of this half cell. So basically it is iron rod dipped into a solution containing Fe dye positives. It is iron rod introduced in a solution carrying Fe dye positive ions. So technically if you see, basically you have got a container. In the container, what do we have? In the container, we have got Fe dye positive ions. And the concentration of Fe dye positive ions here is 0.1 molar. And here in this particular container, we have introduced the iron rod. Perfect. So this setup I'm calling as electrode. And my dear students, we have to calculate oxidation potential of this electrode. Right? We have to calculate its oxidation potential. So to calculate the oxidation potential, let's assume that this electrode behaves like the anode. If it behaves like the anode, then only oxidation takes place. So imagine that this electrode is behaving like anode. When this electrode behaves like anode, oxidation takes place, means loss of electrons. So basically, your reaction is supposed to be Fe solid. It gives Fe dye positive aqueous plus 2 electrons. This is your reaction when this electrode will be behaving like anode. Okay. Now, my dear students, N value here, if you look carefully, N value is 2. QC expression is going to be concentration of Fe dye positive raised power stoichiometric coefficient 1 and concentration of Fe positive is nothing but 0.1. Okay. Now, let's write the Nernst equation. Oxidation potential of the electrode is equal to SOP minus 0.0591 divided by N. It's going to be log of QC, right? How to calculate oxidation potential of the half cell is equal to, this is SOP. How much is SOP? Check this value. Plus 2 to 0, decrease, reduction. This is SRP. What do I need? I need SOP. Reverse the sign. So it is 0.44 minus 0.0591 divided by, what is the N value? N value is 2. Log of QC. QC is 10 raised power minus 1. Log of M raised power N. N log M. So minus 1 comes to the front. Minus 1 comes to the front. So this becomes plus here. Matter of calculation. Solve this. Answer is going to be in volts. Correct? Am I clear, people? Am I clear, people? Yes, a lot of students are saying option B. So I believe it's going to be option B only if you are saying. Okay. What about this one? You have got the reaction. Cell reaction is given. Copper solid plus 2 times Ag positive aqueous. It gives copper dye positive aqueous and what? 2 times Ag solid. This is the reaction that's given to me. First of all, if I ask you what is the N value here, how many moles of electrons are exchanged? 0 to plus 2. That means it has lost 2 moles of electrons. So I would directly say N value here is 2. Okay. We have to calculate equilibrium constant. If we have to calculate equilibrium constant, that means I'll be assuming the cell is at equilibrium. And if cell is at equilibrium, the equation becomes E naught cell is equal to 0.0591 divided by N, and it's log of equilibrium constant. Log of equilibrium constant. As per the question, E naught cell is given 0.46 volts is equal to 0.0591 divided by N value is 2 log of Ke cube to the base 10. Okay. So this becomes 0.92 divided by 0.0591. It approximately comes out to be 15.6. So, right, you got log of equilibrium constant is equal to 15.6. And if log of equilibrium constant is equal to 15.6, I can say equilibrium constant would be equal to NT log of 15.6. How do you get the NT log of 15.6? I hope you remember 15.6 will be broken as 15 plus 0.6. This 15 I'll be directly writing as 10 raised power 15. 0.6 is basically log of 4. So 4 into 10 raised power 15 would be the final answer. Right? Perfect. Perfect, guys. All right. I am moving on to some different questions. Okay, this is also one simple question. We have to calculate standard Gibbs free energy for the given cell. Standard Gibbs free energy means delta G naught. And you know delta G naught is nothing but minus NF E naught. Minus NF E naught. So delta G naught would be equal to minus N value for the reaction. If you look carefully, 0 to plus 2. That means N value is 2. Faraday's constant is how much? Faraday's constant will be 96500 coulombs. E naught is given to me as well, that is 2 volts. But since I have used all the parameters as per SI system, so delta G would be also coming as per SI system. But I do not need delta G in joules, I need delta G in kilojoules, right? I need delta G in kilojoules here. These are the values in kilojoules, by the way. These are the values in kilojoules. So in order to calculate delta G naught in kilojoules, I'll be dividing with 1000. Then only my answer will be coming in kilojoules. Okay? I hope this is also clear to everyone. Simple basic question this is. Only a matter of calculation. That's it. Look at this one. If you look at this question, the electrode potentials for this and this are this and this, calculate this. Okay. See guys, see what this question is. As per this question is concerned, copper dye positive aqueous plus 1 electron. It gives us copper positive. Okay. Its E value is given to me as 0.15 volt. Second reaction, copper positive plus 1 electron gives me copper. Its E value is given to me as 0.5 volt. 0.5 volt. Okay. I have to calculate the E naught for copper dye positive giving copper. Copper dye positive giving copper means copper dye positive has to gain 2 electrons. Then only it will get converted into copper. I have to calculate E value for this particular reaction. Two reactions are given. Their E values are given. This reaction, its E value is to be calculated. Now, what do I need to do? Whenever this sort of a question comes, there will be some reactions whose E value would be given. There would be a reaction whose E value would be we are supposed to calculate. In these sort of questions, remember the reaction whose E value is to be calculated. The reaction whose E value is to be calculated. We are supposed to make this reaction out of the given reactions. Now, how do we make this reaction? The point is, how do we make this reaction? If I do one thing, if I add 1 and 2, this copper positive gets cancelled. This becomes copper dye positive plus 2 electrons gives copper. So can I say third reaction I'm getting? Third reaction. Oh my God, OBS. Is it fine now? Is it fine now? If you think you will do something like this, it's wrong. Why? Because EMF is intensive property and you cannot directly add or subtract the intensive properties. So you have to solve this question in terms of extensive properties. That means you'll be writing delta G3 is equal to delta G1 plus delta G2. This question you'll be solving in terms of delta G, not directly in terms of E. Okay. And delta G3, what is delta G3? Delta G3 is nothing but minus, it is minus N3FE3 is equal. Delta G1 is minus N1FE1. This is delta G2 minus N2FE2. So first of all, F cancels out. So I would say E3 is equal to N1E1 plus N2E2 divided by N3. N1 is given to us, that's 1. N2 is given to us, that's 1. N3 is also given to us, that's 2. E1 we know, E2 we know, put the values and get the answer. That's it. That's it. And my dear students, this is how you are going to solve this sort of a question, by the way. Remember it. Okay? Remember it from now onwards. Don't solve the question in terms of E. Solve the question in terms of delta G. Solve the question in terms of delta G. Look at this one. You're given with a reaction. You're given with a cell. The question says when the concentration of zinc dye positive is 10 times the concentration of copper dye positive. The expression for delta G. The expression for delta G. First of all, if I try to write the net cell reaction here, net cell reaction would be something like this. Zinc solid plus copper dye positive aqueous. It gives zinc dye positive aqueous plus copper solid. This is our net reaction when you make it. This is my net reaction. If this is my net reaction, here N value is equal to 2. And you can write the QC expression. QC is going to be concentration of zinc dye positive divided by concentration of copper dye positive. Now, as per the question, it's mentioned that concentration of zinc dye positive is 10 times the concentration of copper dye positive. So that means concentration of zinc dye positive divided by concentration of copper dye positive is equal to 10. So this value is equal to 10 as per question. Technically, this is what it means. Technically, you got the QC value. Now, my dear students, if you think logically, what do we have to calculate? We have to calculate what? We have to calculate delta G, right? Delta G is what? Delta G is nothing but delta G is equal to minus NF E cell. Minus NF E cell. Okay. But do we know E cell? We do not know E cell value yet. So we have to calculate E cell first. So I would say E cell is equal E naught cell, which is 1.1, minus 2.303 RT divided by NF log of QC. QC is 10. QC is 10. So log of 10 becomes 1. Log of 10 becomes 1. So this is my E cell. This is my E cell. My dear students, if I got my E cell, I can write delta G is equal to minus NF. I'm writing as such. E cell is going to be 1.1 minus 2.303 RT divided by NF. Okay. So delta G is equal to, this becomes minus NF. Sorry. This becomes minus 1.1 NF minus minus plus 2.303 RT. NF gets cancelled here. Okay. So now you know the value of N. N value is 2. If N value is 2, it becomes 2.2F here. 2.2F. So the final answer is going to be 2.303 RT minus 2.2F. So this is the final answer, option C. Am I clear? Am I clear, guys? Is it clear? Asif, this much is enough. This much is enough. All right. Let's check few more questions. Let's have a look on this question. There is something wrong with my stomach. It started hurting. Okay, you give this question a try. Check first of all, will you be able to solve this question? Just honestly tell me yes or no. Quick. Let's have a look. Let's have a look, guys. A reduction potential of this electrode. Al tri-positive Al. Reduction potential of this electrode. Al tri-positive Al. My dear students, if you look carefully, Al tri-positive to Al, we have to calculate reduction potential. So I'll make sure that this electrode behaves like the cathode, because at cathode only reduction takes place. So if this electrode behaves like the cathode, the reaction is supposed to be Al tri-positive plus 3 electrons. It gives Al. This is my reaction, right? N value here is 3. N value here is 3. QC value here is going to be 1 divided by concentration of Al tri-positive. This is QC value. But do we have Al tri-positive concentration anywhere given? No, Al tri-positive concentration is not given. But if you look carefully, there is one more thing that's given to us. What is that? That is pH. My dear students, if pH is given as 12. If pH is 12, what about pOH then? pOH would be 2 because pH plus pOH at 25 degrees centigrade, that's 14. So pOH is equal to 2. If pOH is 2, what would be the OH negative concentration? It would be 10 raised power minus 2 molar. OH negative concentration. It's a good question. 10 raised power minus 2 molar. If you got the OH negative concentration, but I do not need OH negative concentration, what do I need? I need Al tri positive concentration. For that, KSP of AlOH whole thrice is given. AlOH whole thrice. Its KSP is given. First of all, it breaks down into Al tri positive aqueous plus 3 times OH negative aqueous. Okay. If I write the KSP expression, I hope you have studied KSP, solubility product. It is going to be concentration of Al tri positive raised power 1, concentration of OH negative raised power 3. Okay. KSP as per the question is given to me as 10 raised power minus 36 is equal to Al tri positive concentration. OH negative concentration is 10 raised power minus 2. 10 raised power minus 2, 3. It becomes 10 raised power minus 6. So from here I got Al tri positive concentration as 10 raised power minus 30 molar. So I got Al tri positive. So this is 1 divided by 10 raised power minus 30. So eventually it becomes 10 raised power 30. So you got QC. Right? You got QC. If you got QC, now you can use the Nernst equation because we have completed each and everything. Nernst equation says that ERED, reduction potential of the half cell, which we have to calculate, is equal to E naught RED, SRP of the half cell, that which is minus 1.66, minus 0.0591, N value is how much? 3, log of QC. QC is 10 raised power 30. Now it's just a matter of calculation, and here you can calculate the reduction potential of this half cell, which I was supposed to calculate. Did you understand from where I started and where I reached? Sometimes in the question, they won't directly give the concentrations. You have to find concentrations from some other parameters. If they want to make a difficult question, this is one way of making the question slightly difficult for the NEET students. This is one way of doing so, right? They will not be giving the concentration of the ion directly. They'll give some parameter from which you'll be calculating the concentration of the main ion. Okay? Perfect. One simple question, tell me the answer of this one. Tell me the answer of this one. It's simple. Tell me the answer of this one. How much charge is required for the reduction of 1 mole of zinc dye positive into zinc? Zinc dye positive plus 2 electrons give us zinc. This is the reaction. So I would say, how much charge is required for the reduction of 1 mole of zinc dye positive? For the reduction of 1 mole of zinc dye positive, I'll say 2 moles of electrons are required. 2 moles of electrons are required. And you know, charge present on 1 mole of electron is equal to 1 farad. So charge present on 2 moles of electrons would be 2 farad. So 2 farad charge is required. 2 farad means how much? 2 into 96500 coulombs. So this much charge is required for the reduction of 1 mole of zinc dye positive into zinc. Okay? Again, a simple basic question this is, and this is going to be its answer. Similar sort of question. Tell me. The number of farads required to produce 20 grams of calcium from molten calcium chloride. Okay. So basically, calcium is deposited at the electrode. For calcium to be deposited, the reaction should be calcium dye positive plus 2 electrons. Calcium dye positive in the solution should gain 2 electrons. It should finally get converted to calcium solid. And this calcium solid would be deposited at the electrode. As per the question, what mass of calcium is being deposited in grams? 20 grams of calcium is being deposited. 20 grams of calcium is being deposited. The number of farads required. Guys, you can easily solve this question. The number of farads required. First of all, how many moles of calcium are to be deposited? Given mass divided by molar mass. So 0.5 moles of calcium are to be deposited. In order to deposit 1 mole calcium, how many moles of electrons are required? 2 moles of electrons. 2 moles of electrons means 2 farad. 2 farad charge. Right? In order to deposit 1 mole calcium, 2 farad charge is required. So in order to deposit 0.5 moles of calcium, how much charge is required? 1 farad charge is required. Right? 1 farad charge is required. Perfect? I hope this is also clear to everyone. Okay, similar sort of question, which you can easily solve. Tell me its answer in the chats quickly. Tell me its answer in the chats quick. Everybody. This, I believe, everyone should solve easily. Quick, guys, quick. People are saying C. Let's check it out. When 0.1 mole MnO4 dinegative is oxidized, the quantity of electricity required to completely oxidize what? We have to oxidize MnO4 dinegative to what? MnO4 negative. Oxidation state here is +6 for manganese. This is +7. So +6 to +7 means increase oxidation, so loss of electrons. So 1 electron you will write on this side. Okay. So if you look carefully, for the oxidation of 1 mole of MnO4 dinegative, for the oxidation of 1 mole MnO4 dinegative, 1 mole electron is 1 more electron you are seeing here. When 1 mole MnO4 dinegative is oxidized, you have got 1 mole electron here. 1 more electron means 1 farad charge. 1 farad charge means 96500 coulombs of charge. But as per the question, do we have to oxidize 1 mole of MnO4 dinegative or 0.1? I would say 0.1. When 0.1 mole MnO4 dinegative is oxidized, how much charge do we get here? 96500 multiplied by 0.1. The final answer is 96550 coulomb. Right? Option C. Correct? Okay, this question I believe everyone should solve by their eyes closed. Tell me its answer quickly. Faraday's second law is based on what? Velocity, wow, of positive ions. Atomic number of negative ions. Equivalent weights of electrolytes. Right? This is very much predictable and easy question. Tell me the answer of this one. Tell me the answer of this one. The molar conductivity lambda m of a 0.5 molar solution. 0.5 molar solution of AgNO3 is this weight. Okay, conductivity kappa is also given. 5.76 into 10 raised power minus 3 Simon centimeter inverse. What do I need to calculate? I need to calculate lambda m. Lambda m formula is the formula of this question simply. So it is kappa multiplied by 1000 divided by molarity. When lambda m is to be calculated in Simon centimeter square per mole. Okay, kappa is given, molarity is given, put the values, get the answer. That's it. Direct formula based. Direct formula based. Nothing else. Okay. Direct formula based question this was. Again a similar sort of question. And I believe you can easily solve this one as well. The resistance of one normal solution of acetic acid is 250 ohm. When measured in a cell of cell constant, cell constant is given. Equivalent conductance, lambda EQ is equal to kappa multiplied by 1000 divided by normality. Now, normality is given, kappa is not given. We have to calculate kappa, conductivity. 1 divided by R multiplied by L by A. This is the formula. I believe you know it. Kappa is equal to 1 by R. So 1 divided by 250. L by A is the cell constant, 1.15. So here you will get kappa in Simon centimeter inverse. Once you get K, put it here. N is already given and you will be getting the lambda EQ. Again, a basic question this is. Yeah? Formula based, complete formula based. Like you don't have to use any sort of brain here. Okay. First of all, if you talk about Al2SO4 whole thrice, okay, how it undergoes dissociation? 2 times Al tri positive plus 3 times SO4 di negative. Okay. As per the question, the value of lambda naught m, if I write molar conductivity at infinite dilution of Al2SO4 whole thrice, how can I write it? I'll be writing it as 2 times molar conductivity at infinite dilution for Al tri positive plus 3 times molar conductivity at infinite dilution for SO4 di negative. Now in the question, this particular parameter is given, 858 is equal to 2 multiplied by lambda naught m of Al tri positive needs to be calculated. Let this be x plus 3 times lambda naught of SO4 di negative is given. How much is that? 160. So this is 160. Just one equation. Solve this equation. Get the value of x. And what is x? X is basically the molar conductivity at infinite dilution for Al tri positive. Okay. Simple basic question. Again, this was. No need to think a lot about this. No need to think a lot about this particular question. Okay. These are the similar sort of questions which are given. Guys, there are some questions which are repeated here. Okay, I'm not solving those repeated ones. What about this one? What about this particular question? Check it out. Check it out. Check it out, guys. Sir, I never heard you speaking Hindi. पढ़ाएंगे जल्दी आपको हिंदी में भी. Can you give this question a try? बेशिर पढ़ते पढ़ना होते. Done with this? Let's see what the question says. We are given with the cell reaction. Okay. E cell is equal to E naught cell. This is given, pH is equal to X. We have to calculate the value of X. We have to calculate the value of X. Okay. So how do I solve this question? Try to understand what do I do. My dear students, first of all, the cell reaction is given. So if I write QC expression, QC is going to be concentration of Fe di positive raised power 2, right? This is in liquid state, nothing to do with this, divided by solid, nothing to do with this, partial pressure of O2, and with it, concentration of H positive raised power 4. Okay. Now, as per the question, if you look carefully, concentration of Fe di positive is given as 10 raised power minus 3. 10 raised power minus 3 ka square is 10 raised power minus 6 divided by partial pressure of O2. If you see, it is 10 raised power minus 2. So I'm writing 10 raised power minus 2 here, and concentration of H positive. Concentration of H positive. See, as per the question, pH is equal to X. If pH is equal to X, that means concentration of H positive is 10 raised power minus X molar, right? So H positive concentration is 10 raised power minus X raised power 4. It becomes 10 raised power minus 4X. So overall, the value comes out to be 10 raised power minus 4 divided by 10 raised power minus 4X. Okay, this is your QC expression. You got QC expression. Now, guys, understand one thing. If I talk about E cell is basically equal to E naught cell minus 0.0591 divided by N log of QC. This is your E cell expression. This is your E cell expression. My dear students, in the question they have mentioned that E cell is equal to E naught cell. In the question they have mentioned that E cell is equal to E naught cell. Tell me when E cell and E naught cell will be equal. E cell and E naught cell will be only equal if this term is 0. If this term is 0. When this term will become 0? This term will only become 0 if QC value becomes 1. If QC becomes 1. Simple. Because if this is 1, log 1 becomes 0. Then this term becomes 0. Do you understand? A simple tricky question this is. Now QC. QC is nothing but 10 raised power minus 6 divided by 10 raised power, QC is equal to 10 raised power minus 4 divided by 10 raised power minus 4x is equal to 1, which is telling you that 10 raised power minus 4 is equal to 10 raised power minus 4x. So from this equation, x value is equal to 1. And this x I was supposed to calculate. Right? Okay. And with this, your electrochemistry chapter is also over. Guys, my stomach is very much paining. Okay. So, should I give you the slides of solution in the Telegram? You will give it a try on your own. There are some like 60 questions which I have mentioned for solution. And I have mentioned their solution as well. Will you try them on your own? I'm sorry for not doing solution here. Because I don't feel well. Is that okay? See, I have shown you all the types of the questions that can be asked from electro. In electro, they are not going to ask anything apart from this. Okay? In electro and your kinetics, they are not going to ask you anything apart from these. Perfect? We know where they can reach. Okay? Hello, I'll take a leave with this. Acha, these slides I'll be sharing on the Telegram. Wassim Bhat Chemistry Official is the Telegram channel name. Wassim Bhat Chemistry Official. Join that Telegram. I'll be sharing these handwritten slides there. Okay, and please try these questions of solution. Okay, I've given the solution of each and every question here in the slides itself. Try them out. And do let me know afterwards in the comment section of this video whether you liked the session. Do you want more of these sessions or not? Okay, I'll be taking a leave here, guys. Take care. God bless you.